Hello friends, welcome to the world of ethical hacking. In this course, I am gonna teach you ethical hacking. By the end of it, you will be at a high intermediate level. So, we will start by teaching you how to set up a pen testing lab and how to install the needed software so you can practice hacking safely. Once done, the course is divided into four main penetration types: network hacking, gaining access, post exploitation, and website hacking. The first is network hacking section where you learn how network works and how devices communicate with each other and how to exploit this method of communication to control all the connection around you. Crack the Wi-Fi keys and gain access to Wi-Fi networks, whether they use WEP, WPA or WPA2, and intercept data to capture usernames, passwords, chat messages, or anything that anybody does on the same network. Once done with this, we will move to the gaining access section where you learn how to gain access to servers and personal computers. So first, you will learn how to gather comprehensive information about your target, discover vulnerabilities, and exploit them to gain full control over the target system. Not only that, but you will also learn how to generate undetectable backdoors and use social engineering to deliver them. You will also learn how to spoof emails so when they are delivered to your target, they appear as if they are sent from a friend, from their boss, or from any address that they are likely to interact with. Once done with all of this, we will move to the post exploitation section where you will learn what can you do with the access that you gain in the previous sections. So you will learn how to interact with the file system and how to execute system commands, record keystrokes, open the webcams, and even use the hacked computer as a pivot to hack into other computers. Once done with all of this, we will move to the website hacking section where you will learn how website work, how to gather comprehensive information about your target website, and how to discover and exploit a number of dangerous vulnerabilities that allows you to gain a full control over the target website. At the end of each section, you will learn how to secure systems and secure yourself from discuss attack. Thank you and see you in the next video. Welcome. Today we are diving into the fascinating world of the ethical hacking. We will explore what hacking is, the different types of hackers, and why ethical hacking is crucial industry. Now we will move to what is hacking. Hacking is the act of gaining unauthorized access to the computer system or networks. It involves exploiting security vulnerabilities to bypass defenses, allowing the hackers to take control. This can lead to data theft, service disruption, or even more malicious activities. Not all hackers are the same. We categorize them into three main types: black hat hacker, white hat hacker, and grey hat hacker. Now we will discuss about black hat hacker. Black hat hacker are the bad guys. They illegally hack systems to steal money, disrupt service, or achieve other illegal goals. Their actions are purely malicious. Example: a notorious black hat hacking group known as Revil was responsible for large-scale ransomware attack in 2021. Targeting companies worldwide, they encrypted data and demanded millions of the dollars in ransom, showing how dangerous and disruptive black hat hackers can be. White hat hackers. White hat hackers use the same technique as black hat, but there are key differences. They have permission. These ethical hackers test system security to protect against future attacks. Their goal is to improve defense, not break them. In real life example, 2016, a white hat hacker named Anand Prakash discovered a major security flaw in Facebook's login process that could allow attackers to take over accounts. Instead of exploiting it, he reported it to Facebook, which is earned him a 15,000 US dollar reward. Grey hat hackers. Grey hat hackers sit between the two. They may hack into the system without permission, but they don't have malicious intent. Instead, they often inform the system's administrator of the vulnerabilities. They find they are like ethical hackers, but they don't always follow the rules. Now, one big question that people always ask, why hacking? So, the hacking industry is huge, and ethical hacking in particular is growing rapidly. There is a high demand for skilled professionals who can secure systems and protect sensitive data. By becoming an ethical hacker, you are not just finding vulnerabilities, you are helping to secure the digital world. There is actual a huge demand for ethical hackers these days because of the increased amount of hacking attacks. So we hear on the daily big systems and big companies are getting hacked. So companies they hire hackers in order to try and hack their system and tell them where the weakness are so that they can fix it. They also have bug bounty program where they can literally ask all the hackers around the world to go ahead and try to hack into website and within their website applications they could will pay them bug bounty for the finding bug. Welcome back to this course on ethical hacking. In this session, we will focus on one of the most critical steps in your ethical hacking journey, setting up a dedicated hacking lab. This lab will serve as a safe, controlled environment where you can practice your skill legally and ethically. In our next slide, we will discuss how to set up the key component of your hacking lab. Setting a hacking lab to effectively learn and apply ethical hacking techniques, it's essential to create a hacking lab. This lab will be your testing ground, ensuring that you have an isolated environment where you can explore vulnerabilities, test tools, and refine your techniques without affecting live systems. Next, let's dive into the specific component you have need to up your hacking lab. The lab component. So, what do you need for your lab? Here is a quick overview of main component: a hacking machine. This will be your primary tool for conducting pen test. A target machine. This is the system you will practice hacking on. A website to hack. You can set up vulnerable web application to test web-based attacks. Networks. You can simulate different network environments to practice network security attacks on defenses. Up next, we will explore how virtual machines play a key role in setting up a hacking lab. Virtual machines. One of the best way to set up your hacking lab is by using virtual machines or VMs. Virtual machines allow single physical computer to run multiple operating systems simultaneously. This means you can simulate different operating systems like Windows or Linux or etc. Next, we will look at the key benefit of using virtual machine. Benefits of virtualizations. Let's look at some of the key benefits of virtualization for ethical hacking. You can install multiple operating systems on your current machine, reducing hardware cost. Each virtual machine has its own resources and behave like a real machine, making it perfect for realistic testing. If something goes wrong, fixing or resetting the VM is quick and easy. And most important, VMs are isolated from the host system. This means that if any vulnerability are exploiting during testing, your main system remains secure. Before we move on the Kali Linux, let's make sure you have the right virtualization software. One of the most popular option for running virtual machine is VMware. Let's walk through how to download and install VMware on your system. First, go to the official website, VMware website, and go to the product section and scroll down and see desktop hypervisor and click on desktop hypervisor and scroll down and download for PC. And after downloading, once you have set up the virtual machine, we will discuss on how to install and configure the Kali Linux for into your hacking lab. Stay focused and continue learning. In the next session, we will cover Kali Linux installation and setup. Let's move on to the next video. Welcome back to the course. In this lesson, we will walk through the process of installing Kali Linux from jetsecurity.org. Kali Linux is a powerful operating system specially designed for ethical hackers. And by the end of this video, you will have it fully set up system. Let's get started by downloading Kali Linux. There are additional tools in customized Kali Linux downloaded from this website, which we will see later in course. You can install Kali Linux file by clicking link 1, link 2 or torrent, etc. Now click on download button. The downloading process is getting started. After the downloading completed, after the Kali Linux is installed, unzip and extract it to a specific folder. Open VMware, open virtual machine, locate the file where you extract the zip, open the VM file and power on the virtual machine. And wait for the process and loading. It takes some time. See, when it's done, click enter username, root, and password PRR tools. You can see the homepage of Kali Linux desktop, and here is the UI of the Kali Linux. You can change configuration of device according to your system requirements. You can change RAM, memory, processor, hard disks, etc. You can set according to your system requirement and system supports. You can set up to processor, hard disk size. Welcome back to this course on ethical hacking. Hello everyone. Now that we have Kali Linux installed, let's dive into a basic overview of this operating system. Kali Linux will be our primary tool throughout this course, and understanding its interface will make everything much easier as we progress. First, let's talk about the status bar. On the top left, you will find the application menu. All the tools are categorized here, making it easy to find what you need, whether it's information gathering, vulnerability analysis, or reverse engineering. You can explore and run any program directly from this menu. Next is the Places menu, which gives you quick access to a common file location like home, documents, downloads, music, pictures, videos, etc. or by simply clicking on the files icon on the left sidebar. Both options take you to your home directory. While it says home, the actual location is the root directory, which you can see by pressing Ctrl L. Here is root directory. Kernel Linux comes with multiple workspaces by default. These are like virtual desktop that let you organize tasks efficiently. Like this, you can switch into workspaces. You can switch between workspace using the workspace switcher on the top bar or by on the far right of the status bar. You will find control for volume, network connection and power setting. Right now it show you are connected to a wired network because I will configure Kali to use a net adapter. If you are using a wireless adapter, it will show up here. However, the Kali only supports external USB adapter for Wi-Fi connection. Still, you should have internet access to the net configuration, just like when I load Google. In the same area, you will also see battery and user settings. You can access system preference here to adjust Bluetooth, Wi-Fi display, setting, or even change your background and language. Kali's file manager is very intuitive. You can easily navigate through your file, extract archives, and manage deleted items in the task. On the left, you also have a dock with your favorite application. By clicking the Show Applications, you can access menu of your most used tools or view all installed applications. So that a quick tour of Kali Linux. As you get familiar with it, things will become even easier. Spend some time exploring and don't worry, we will dive into more detail as we progress through the course. See you in the next session. Welcome back. Now that we will cover a basic overview of a Kali Linux, let's dive into one of the most important tools you will be using, the Linux terminal. You can access it by clicking on this application right here, and as you can see, it opens a black screen where we can type the command. The Linux terminal is extremely powerful. In fact, many applications in Linux with graphical interface started as a terminal program. Sometimes the graphical interface might crash or be buggy, but the terminal will still work perfectly. Moreover, most penetration testing tools in Kali Linux does not even have a graphical interface. They only run through the terminal. This is why knowing how to use the terminal is crucial, especially when you might only have a command line access. Throughout this course, we will be using the terminal a lot. So let's start with some basic command and get you comfortable. The terminal works by typing commands and the result is displayed on the screen. Let's start with the simple command pwd, which stands for printing working directory. If I type pwd and press enter, you can see it prints root directory. Means we are currently in the root directory. Let's use the ls command. This command lists all the files and directories in the current working directory. If I type and press enter, you will see a list of all the directory here in root. Now if we want to navigate to another directory, we use the cd command, which stands for change directory. For example, if I want to go to the download folder, I just type cd download, cd, cd downloads and press hit enter. Now if I type pwd, you will see I am inside root slash download folders. If I run ls again, it will show me all the files in the directory. To go back one directory, all you have to do is type cd dot dot and press enter. Now if I type pwd, I am back in the root directory. If I type ls, I can see all the files and directory here again. There are many Linux commands and you don't have to memorize them all. You will naturally learn them as we can go through the course. But if you ever need help understanding how a command works, you can use the man command to view the manual. For instance, if I type a man ls, it will open the manual for ls command. It tells us that ls list directory contents and it shows us how to use it with different options like -a to show hidden files or -l for long listing format with more details about this file. Let's try the long listing format. I will press Q for exit the manual. Then type ls -l to display more detailed information about the file. As you can see, it gives us more information like file permission and size. The man command works with any command, not just ls. You can use it with pwd, cd or any other command. So that's a basic introduction to use the Linux terminal. As we continue, you will get more familiar with these commands. Don't worry, we will go over them step by step throughout the course. Keep practicing and I will see you in the next video.
Welcome to the network hacking section of our ethical hacking course. This is where we dive into how systems communicate over networks and explore vulnerabilities that can be exploited. Why start with network hacking? Well, think about it. Everything today is connected to a network. Whether it's a personal computer, a server, a company's internal system, or even just a website, they all communicate through networks. The internet itself is nothing more than a massive network. Understanding how networks work and how devices within this network communicate is absolutely essential before we move to understanding how networks work and how devices within this network communicate is absolutely essential before we move on the other aspect of hacking. This section will be divided into three main subsections. In the first subsection, pre-connection attacks. We will focus on attacks you can perform before connecting to any network. Imagine you have a device with a network interface or Wi-Fi adapter. What can you do before even connecting? Well, explore techniques to gather information and test vulnerabilities without establishing a connection. Next, we move on the Next, we move on the cracking Wi-Fi networks, whether it's WEP, WPA or WPA2 encryption. We will learn how to crack those Wi-Fi keys and gain access to secure networks. Once you have gained access, the doors open for a range of possibilities. Finally, the third subsection is where things get really interesting. Whether you are on a Wi-Fi or wired network, you will learn how to execute powerful attacks once you have connected. In this part, you will discover how to intercept traffic, capture usernames, passwords, URLs, and even chat messages. And that's just beginning. But it does not stop there. You will also learn how to modify data on the fly, when to inject malicious code into web pages as they load, how about service fake, how about serving fake updates to users. The possibilities are endless. So, get ready to dive deep into the network hacking section. By the end of this section, you will have a solid understanding of how to exploit vulnerabilities within both Wi-Fi and wired networks. So, let's get started.
Welcome to the ethical hacking course. Before we dive into network hacking, it's important to first understand how network work and we connect to a network every day, often without even thinking about it. Whether it's through Wi-Fi or wired connection, we use networks to share data or access resources like the internet. In fact, the internet is the best example of resource we connect to every day. All networks follow a basic structure. At the center of most networks, there is a device that controls everything. This is called the server or access point. For home networks, this device is usually your router. Think of the router as the gateway of the internet. Your computer or phone can directly connect to the internet. It has to go through the router first. Here is an example. Imagine you are on your computer and you went to visit google.com. When you type that into your browser, your computer sends a request to the router. The router then connects to the internet, finds google.com and sends the information back to your computer. Your browser then shows the web page. The router is the only device in your home network that has the direct connection to the internet. Every other device, whether it's your phone, laptop or tablet has to go through the router to get online. Data travels back and forth between your devices and the router in the form of packets. These packets carry information like your request. For example, if you are on a Wi-Fi network, these packets are sent through the air. Because these packets are in the air, if you have the right tools and you are within the range, you can capture and read them. By capturing these packets, you can see what other devices on the same network are doing online. You can see the website they visit and even sensitive data like usernames and passwords. We will dive deeper into how you can capture and analyze these packets in upcoming lessons. But for now, this basic understanding of how network work operate will help you grasp the existing things we are about to explore. Stay tuned as we start to look at some cool network attacks. Welcome back to this course of physical hacking. In this video, I am going to show you how to connect a USB device, especially a wireless adapter, to your virtual machine in VMware. I will be using a Kali Linux for this demo, but you can follow the same step for every virtual machine and any USB device. As mentioned in the course requirements, you will need a Wi-Fi adapter for the Wi-Fi cracking section. This is the part where we'll be showing you how to crack Wi-Fi password. However, for other sections of the course, you won't need the adapter. Now, when I say adapter, I am talking about USB device that connects to your computer and allows it to communicate with wireless networks. Most computers and laptops have built-in wireless cards, but here is the issue. VMware does not allow direct access to this built-in wireless card. Even if it did, this card does not support advanced hacking features like monitor mode and packet injection, which are essential for network hacking. That's why I recommend using an external wireless adapter, like the one listed in the course requirements. Let's get started. First, open a VMware and select virtual machine you want to connect your wireless adapter to. In this case, I am using Kali Linux. And go to setting. Once there, navigate to USB controller. Make sure the USB controller is enabled and select the USB version that matches your adapter. Most wireless adapters use USB 2.0 or 3.0. So for this demonstration, I am selecting 2.0. Once the adapter is connected, VMware will recognize it. Once the adapter is connected, VMware will recognize it. The name you see here might not match the brand name of your adapter. It usually shows the chipset name like Atheros or Realtek. In my case, it's showing Realtek, which is my adapter. The wireless adapter is now ready to be used with Kali. Or log into Kali with username and passwords. To make sure the adapter is connected to Kali, go to the VM menu at the top and click Removable Devices. And select the adapter from the list. If it's not checked, go ahead and click on it to enable it. For me, it's already checked. Let's confirm that the adapter is successfully connected. Open the terminal in Kali and type ifconfig. This command lists all network interface connected to the machine. If your adapter is connected, you will see an interface called WLAN 0. This confirms the adapter is recognized and ready to use. You also notice the Wi-Fi icon at the top right corner of the screen. We won't need to connect Wi-Fi right now because Kali already has internet through a net adapter. But this shows that the adapter is ready for a Wi-Fi related task like hacking. And that's it. Your wireless adapter is now connected to your virtual machine in VMware. And you are ready to start hacking into wireless networks in the upcoming lessons. In further lesson, we will go into more detail about using monitor mode, packet injection, and much more. Stay tuned for more hands-on hacking techniques. Hello everyone, welcome back to this course of ethical hacking. In this video, we will talk about something called a MAC address. You have probably heard this term in network hacking. So let's break it down. What is a MAC address? What it used for? And how you can change it. MAC address stands for a Media Access Control Address. It's unique and permanent address given to each network device like your Wi-Fi card or Ethernet card by the manufacturer. No two devices in the world will ever have the same MAC address. Think of it like your device fingerprint. Even if you unplug that network device from the one computer and connect it to another. The MAC address will always stay the same. You might already know that an IP address is used for identify computers on the internet. A MAC address works a little differently. It's used within a network identify device and helps transfer data between them. Every data packet sent over a network has a source MAC address where it's coming from and a destination MAC address where it's going. Since the MAC address is unique to each device, changing it can help you to stay anonymous on their network. For example, some networks only allow specific device to connect based on their MAC addresses. By changing your MAC addresses, you can pretend to be a different device, bypass filters, or hide your real identity. Now let's talk about how to change your MAC address. Don't worry, it's really simple. Open terminal and we will use ifconfig command in Kali Linux to list all the network's interface. Network interfaces are devices like Wi-Fi cards or Ethernet port that allow us to connect networks. For example, on my machine, I have a virtual network interface called ETH0 and a wireless interface called WLAN0. Each interface has its own MAC address, which you can see listed under Ether. For the interface WLAN0, we will be changing the MAC address. First, we need to disable the interface before making any changes. To do this, we will type ifconfig WLAN0 down. Config Now let's change the MAC addresses. We will type ifconfig WLAN0 HW HR and followed by the new MAC address. We went 009988776655 and hit enter. No error message. That means the MAC address has been successfully changed. Finally, we are re-enable the interface by typing ifconfig WLAN up. Now the interface is back online, and if we check again using ifconfig, you will see the MAC address has changed to the new one. Just keep in mind, this change is temporary. When you restart your computer, the MAC address will reset to its original value. If it reset before that, it might be because your network manager is resetting it. That's it. You now know to what a MAC address is, how it's used, and how to change it. This can be really useful for staying anonymous or bypassing certain network filters. In the next lesson, we will continue exploring more existing network hacks. See you soon. Hello everyone. Welcome back to this course of ethical hacking. In the previous lesson, we learned how networks work and how data is sent as a packet between devices. Whether you are watching a video, sending a chat messages, or checking emails, everything is just sent as a packet. Each packet has a source MAC address and a destination MAC address. It travels from the source to the destination device. Let's say we have a client device with one MAC address and an access point with another MAC address. If the client wants to send data to the router, it will use the router's MAC address as the destination. Normally, a device only receives packets that are meant for it, packets that have its own MAC address as the destination. But in wireless network, if you are in within the range, you can capture all the packets because they are sent through the air. Even if the packets are not meant for your device, you can still capture them. To capture all these packets, you need to switch your wireless interface to monitor mode. Let me show you how to do this. First, open your terminal and run the command iwconfig. Here you can see WLAN0, which is my external Wi-Fi adapter. Currently it's set to manage mode. This is the default mode where the adapter only captures packets meant for it. But we want to capture all the packets in the range. So we need to switch to monitor mode. First you need to disable the interface. Type ifconfig and 0 down. To do this, after that, it's a good idea to run a command to stop any process that might interfere with monitor mode. Now let's enable a monitor mode. Type iwconfig LAN mode monitor. This command sets the mode to monitor. If you see no error, the command works. Then you enable the interface by typing ifconfig LAN up. Run iwconfig again and you should see that the mode is now set to monitor. Your interface can now capture any packets within the range, not just those meant for your device. In future lessons, when I mention using monitor mode, this is what I mean. You will need to enable monitor mode as shown. One last thing, not all wireless adapters support monitor mode. Make sure your adapter does. That's it for now. You are all set for start capturing packets in monitor mode. See you in the next lesson where we will dive deeper into network analysis and security. See you soon. Hello friends, welcome back to this course of ethical hacking. Today we are diving into a cool concept called packet sniffing. This is where we capture data packets flying around on a Wi-Fi networks. Don't worry, I will explain in these easy terms. Imagine you are sitting in a room with the people talking. You can hear what they are saying, even if they are not talking to you. Packet sniffing is kind of like that, but Wi-Fi signals. You can listen to packets of data being sent, even if they are not meant for your device. To sniff these packets, we need to put our wireless adapter into monitor mode. This lets us see all the packets in the air, not just one for meant for us. Once monitor mode is on, this tool captures all the Wi-Fi packets around us and shows useful information like network name, signal strength, and even encryption types. Using arrow dump ng is just typing arrow dump ng, followed by the name of our wireless adapter in monitor mode, like this, WLAN 0. Hit enter. You will see all the nearby Wi-Fi networks. Let me explain what we are seeing here. BSSID. This is the MAC address of the network. PWR means for power. The strength of the Wi-Fi signals. Beacons. RAM sent to anonymous the network presence channel. The Wi-Fi channel the network is using. Encryption. This show if the network is secured with WPA or WPA2 or it's open. So that's packet sniffing in a nutshell. Don't worry if this seems a bit technical right now. We will dive deeper into tool into our upcoming lessons and you will get the hang of it. Stay tuned for more existing stuff. Hello everyone, welcome back to the course of ethical hacking. In today's video, we are going to talk about Wi-Fi bands, especially 2.4 GHz and 5 GHz. These are the two main frequencies used in Wi-Fi networks, and understanding them will help you to make better use of wireless connection. So, what exactly is the Wi-Fi band? Well, it is the frequency at which your Wi-Fi signal is broadcast. Devices like your laptop or phone need to support that frequency to connect. The two most common frequencies are 2.4 GHz and 5 GHz. Each has its own strength and weakness. The 2.4 GHz is great for long range conditions. It can travel further and penetrate walls better than 5 GHz, but it is more crowded. Many devices like microwaves, baby monitors, and Bluetooth all operate on the 2.4 GHz band, which can lead to interfaces. Now the 5 GHz band. The 5 GHz band is faster and less crowded. It gives you better speed and performance, but its range is shorter. It does not travel through the wall as well, so it's best for close range conditions. Let's open terminal and type arrow com ng and your wireless interface name. When using tools like AeroDump for Wi-Fi sniffing, you might notice that you only see networks on the 2.4 GHz band. That's because your adapter might not support 5 GHz or the tool is only scanning the 2.4 GHz frequency by default. For example, in my setup, I can see networks around me when I run AeroDump, but I might not see networks with 5G in their name because they are broadcasting on the 5 GHz band. Not all wireless adapters support both 2.4 GHz and 5 GHz band. My adapter, for example, is excellent for 2.4 GHz but does not support 5 GHz network. To sniff on the 5 GHz band using AeroDump, you can add the band A argument if you want to capture both 2.4 GHz and 5 GHz at the same time. You can use band A. Just keep in mind, capturing on the multiple bands requires a powerful adapter. In summary, 2.4 GHz is better for range and 5 GHz is better for speed. Depending on your needs, you might switch between the two, but make sure your device or adapter supports the frequency you want to use. That's it for today's video. See you in the next lesson. Hello everyone, welcome back to our ethical hacking course. In the last lecture, we learned how to use AirDub-NG to scan all the networks around us and get useful information about them. Usually, we do this to find our target network, check its signal strength, and see how far we are from it before we start attacking it. Today, I will show you how to focus on just one specific network using AirDump-NG to gather detailed information about that network. So let's my target device is this one, the same network my host machine is connected to. Now that I have my target, let's see how we can run AirDump-NG on this network only. Instead of scanning all the networks, first we will start by typing the name of AirDump-NG. Next, we need to specify the BSS ID. This is the MAC address of this network. We will copy the BSS ID of our target network and use the hyphen hyphen BSS ID followed by the BSS ID and paste here. After that, we need to tell AirDump-NG the target network is on channel 11. So I will use the command hyphen hyphen channel and set it to 11. Now we are telling AirDump-NG focus on channel 11 and only gather data from the network with the BSS ID we specified. Next, we want to save all the captured data into a file. So we will use hyphen hyphen write and name the file test. Finally, I will provide the name of my wireless adapter in monitor mode. In my case, is blend 0. So the full command is ready. Let's go over the command once more. We are using AirDump-NG, specifying the BSS ID, getting the channel to 11, telling it to write the captured data into a file called test using the wireless adapter LAN 0 in monitor mode. Now I will hit enter. As you can see, AirDump-NG is now showing me one network, the one I went to sniff on. You can also see new section here showing the clients or device connected to this network. These are the MAC addresses of the device using this network. You can check their signal strength, speed, how much data is lost, and how many packets have been captured. If this device are trying to connect to other network, you will see the information under the probe section. When I press Ctrl C, AirDump-NG will stop, but the data we capture is now saved in my working directory. Since we use hyphen hyphen write option, the data was saved into files starting with test. You will notice 4 files with different extension: CSV, netXML, cap, and Kismet. So remember, the main file we care about is the cap file. This contains all the data sent between the router and the client during the capture period. This could include URLs, usernames, and even passwords, because all the traffic passes through the router. But there is a catch. The target network is using WPA2 encryption, which means all the data we captured in encrypted. Let me show you what that look like. I will open the .cap file in Wireshark, a tool for analyze network data. Don't worry about Wireshark for now. We will cover it later on this course. For now, just know that while we can capture packets, they are encrypted. As you can see, when I click any package, the data look like gibberish. This is because of the WPA2 encryption. And that's it for today's lesson. We have focused on how to use AirDump-NG to target one specific network and save the captured data for later analysis. See you in the next lesson. Welcome back to the ethical hacking course. Before we dive into more advanced topics like breaking encryptions and gaining access to network, I want to show you one last quick connection attack, the de-authentication attack. This attack is super useful and interesting. Here is why. Imagine you want to disconnect any device from Wi-Fi network without even needing the password. Yes, it's possible. With a de-authentication attack, we can force a device to disconnect from a network. It's like saying, hey, you are kicked out, but without touching the device or knowing the Wi-Fi password. How does it work? We will take both the device and the router. First, we will change our computer's MAC address to the target MAC address and tell the router, hey, I want to disconnect. Then we will change our MAC address again to pretend we are the router and tell the target device you have been disconnected. Simple, right? But don't worry, we won't do this manually. We will use a tool called AirPlay NG. In previous section, you target the one network and here is the interface and here is the two devices connected to the network. Let's get started in this demo. I will disconnect my own device from my network. Right now, we will run a simple command in Kali Linux. AirPlay -ng -d thousand of packets -a a router MAC -c a client MAC address and our wireless network interface LAN 0. AirPlay NG is the tool. DWAT means we are doing authentication attack. 1000 is the number of DWAT packets we want to send. -A is the router's MAC address. -c is the client MAC address. LAN is the my wireless adapter in monitor mode. Let's run the command. You see the attacks begin start. And my Wi-Fi is successfully disconnected from my device. My device is disconnected from the network and it won't reconnect until I stop the attack. To reconnect, I just need to stop AirPlay NG, Control C. Now connected Wi-Fi successfully into my device. Why is this useful? This attack has a lot of real-world uses. For example, in social engineering, you can disconnect someone and pretend to be a tech support to trick them into installing malware. Or you can use it to capture WPA handshake needed for a cracking Wi-Fi password, which we will cover later. So this tool attacks can be a powerful tool when used as part of your attacks. That's it for the DOT attack. In the next lesson, we will dive deeper into more advanced network hacking techniques. Stay tuned. Hello friends, welcome back to the ethical hacking course. Today we are going to talk about how attackers gain access to a different types of computer devices. And when I say computer devices, I don't just mean laptops or desktops. I mean anything that has an operating system. This includes your phone, TV, web servers, websites, routers. Basically, all of these are computers. Every device you see works just like a computer. They have operating systems and programs installed on them. And these systems are used by people. Whether it's a Windows or Linux system, the concept of gaining access to this device are very similar. In this video, we will focus on two main targets, a Windows device and a Linux device. But remember, you can apply the same idea to the phone, tablets, or even the web servers. The first approach we will talk about is server-side attacks. This type of attack does not need any user interaction. For example, think about a web server or a device that runs on its own. We will use the device IP address to see how secure it is and how we can gain access. Our focus here will be on the operating system and the applications running on that system. Now let's look at the client-side attack. This kind of attack needs the user to do something like opening a file, installing an update, or even clicking on a picture. We will learn how to create trojans, backdoors, and how to trick user into giving us access. This is where social engineering comes into play. We gather information about the person so we can target them effectively. Once we can gain access to the target device, what can we do next? Whether it's through a server-side or client-side attack, or even physical access, we will discuss how to further exploit the system. This includes increasing privileges or even targeting other computers in the same network. So, in the next part, we will dive deeper into this method and show you how attackers gain access to a different devices. Stay tuned and make sure to secure your system. Hello everyone, welcome back to the ethical hacking course. Today we are diving into the basics of cracking WEP encryption, also known as wired equivalent privacy. Now, web is an old encryption method and frankly, not very secure anymore. But it's still important to learn because not it is a great starting point for understanding wireless security. But you might still encounter networks that use it. As ethical hackers, we don't want to stump it when faced with WP, right? In this video, I will explain how web works and highlight the main vulnerabilities that we can exploit to break it. In the next video, we will go through the process of using that weakness to the crack WP and get the network key. So let's get started with how web encryption works. Webs use an algorithm called RC4 to encrypt data. Imagine a client went to send data to a router before it sends anything. It encrypts the data using a key. This turns readable data into what looks like a random gibberish. This encrypted packet is then sent over the air. If a hacker intercepts this packet, all they will see the gibberish. They won't be able to make sense of the data because it's encrypted. However, when the router receives these packets, it can decrypt it using a key that matches the one the client used. The same process happens when the router sends data back to the client. It's encrypted first, then decrypted on the other side. Now, here is the tricky part. RC4 itself is fine. The problem lies in how web implements it. Web tries to make sure each data packet has a unique key by generating a 24-bit random number called a initialization vector. This is IV combined with the network's password to create the key stream, which is then used to encrypt the data. The IV is included in the packets along with the encrypted data. But here is the catch. The IV is sent in a plain text. This means anyone intercepting the package can see the IVs clearly. The IV is only 24 bits long, which is not a large enough number to keep things secure, especially on a busy network. As more packets are sent, IVs start to repeat, making the encryption vulnerable to a statistical attack. Using a tool like AirCrackNG, we can collect enough packets with repeated IVs and eventually determine the key stream. From there, cracking web and getting the network's key becomes possible. So that's the theory behind why web is vulnerable and how we can crack it. In this next video, I will show you exactly how to use AnyCrackNG to break web encryption and gain access to a network. Hello friends, welcome back to the ethical hacking course. So in the previous lecture, we discussed the theory behind web cracking. Today we will take it a step further and perform it in practice. To crack web encryption, the first thing we need a large number of packets or IVs. These IVs are short and will eventually repeat, which allow us to perform a statistical attack using the tool AirCrackNG. We will begin by using AeroDumpNG to capture packets. I have already set my wireless adapter into monitor mode and its name LAN0. Running AeroDumpNG lists all the networks around me. And as you can see, we have one network using web. It's called GNXS 2.4 GHz. For the purpose of this demo, I have configured this network to use web. Next, I am going to target the network by running AeroDumpNG with the BSS ID, copy that and paste here, and channel number specified. I will also use the write command to save the captured data into file name basic web and use wireless adapter in monitor mode is LAN 0. So let's run this command. As you can see, AeroDumpNG is actively capturing packets from my target network and the data counts is increasing quickly. This is because it's a busy network with several devices connected. Here is an important point. The data column represents the number of useful packets containing unique IVs, which are crucial for cracking the key. The more IVs we capture, the more likely we will be able to break the encryption. Once we have captured enough data, the next step is to use AirCrackNG to crack the key from the captured file, which is the .cap file. Let's run AirCrackNG, AirCrackNG with the file name basic web.cap file and hit enter. Success, the web key has been cracked. We can now use this key to connect to the network. I am going to use the crack key to connect to the network. As you can see, I have removed the colons and entered the key into the password field. Let's connect. We are connected. Now let's test the connection by opening a browser and visiting a google.com. Google loads successfully on screen. And there you have it. We have successfully cracked the web encryption and connected to the target network. So that's how you crack a web protected network. In the next lecture, we will dive deeper into more complex scenarios like when the network is not busy. Until then, keep practicing and exploring. Let's move to the next video. Hello friends, welcome back to the ethical hacking course. In the previous lecture, we saw just how simple it can be to crack web encryption and capture enough data using AirCrackNG. But there is one challenge you might face, a quiet or slow network. If the network is not busy, the data we need to crack the key will increase really slowly. This means we had been waiting for hours before gathering enough information to break the encryption. So, how do we speed things up? Let's jump into an example. I am running AeroDump-ng to list all the networks around me, and here is my test network, GNXS 2.4 GHz, and it's using web. But look at the data count. It's sitting at 0, barely moving. A solution, we can focus the network to generate new packets with the new IVs. But before we can do that, we need to associate with the target network. Association does not mean connecting. We are not joining the network because we don't have the password yet. What we are doing is telling the access point, hey, I want to talk to you, so don't ignore my request. Now let's associate with the network. I am running AeroDump ng with the target network BSS ID. And here to copy the MAC address of your target network and paste here and set the channel. My network's channel number is 1. And I will save the data in a file called ARP replay because that is the attack we will be using. As you can see, the data is increasing very slowly, so we need to speed things up. To associate, we will be using AirPlay-ng with the fake authentication attack. AirPlay-ng fake auth, put 0 for do only once, and -a target at MAC address, and -h my wireless adapter's MAC address. Copy the first 12 digits and paste here after -h and replace hyphens to colons. And enter our wireless adapter, and I will run the command. Done. Notice under auth, it now says open and show a new client. My wireless adapter is associated with the network. But remember, I am not connected yet. In the next lecture, I will show you how to use this association to inject packets, making the network generate enough data for us to crack the web key quickly. Stay tuned and let's move to the next video. Hello friends, welcome back to the ethical hacking course. Now that we have successfully associated with our target network, we can finally start interacting with it. This means the network will no longer ignore us. So what's next? We can begin injecting packets into the network traffic to force the access point to create a new packets with the fresh IVs. This process will speed things up dramatically, allowing us to crack web network in just a few minutes. Even on a quiet network like the one we are targeting right now, there are different ways to achieve this. But in this course, we will focus on the most reliable method, the ARP request replay method. There are different ways to achieve this, but in this course, we will focus on the most reliable method, the ARP request replay attack. Other methods exist, but they are more complex and less reliable. This attack works on most networks as long as you have a strong signal and a good wireless adapter. Here is how it works. We wait for an ARP packet. Don't worry, I will explain ARP in more detail later on. For now, just know it is a special type of network packet we are looking for. Once this packet is transmitted on the network, we capture it and retransmit it. This forces the router to create a new packet with a new IV. And by repeating this process, we continuously force the router to generate new packets with the new IVs. Once we have enough data, enough IVs, we can run aircrack ng just like we did before. To crack the key, as you can see, I am already running aerodrome ng against our target network and I have associated with it. Now, the only things left is to run the ARP replay attack to inject packets and get the router to generate more packets with the new IVs. To do this, we will use airplay ng. I will copy this command and modify a few things. First, we are not doing a fake authentication attack. So I will remove that part. We are going to run an ARP replay attack instead. ARP replay, and this attack does not need a number. So I will be removed. Lastly, I will replace the A with the B to signify ARP replay. If you look closely, the command is almost identical. We are using airplay ng, but instead of fake authentication, we are doing an ARP replay attack. The MAC address of target network comes after B, and my wireless adapter's MAC address after S, just like before. Then we specify the adapter in monitor mode. Now my adapter is waiting for ARP request packets. As soon as one is sent in the network, it will capture and retransmit it, forcing the router to create a new packet with a fresh IV. We will keep repeating this to generate more packets. And there we go. The number of data packets is increasing quickly, which means we successfully captured and retransmitted an ARP packet. The router is now generating new packets with new IVs continuously. The router is now generating new packets with new IVs continuously. With enough data, we can now run with, with enough net with enough data, we can now run ng to crack the network. Crack ng, and let's do that. I will associate one more time and then run aircrack ng with the file containing the captured data. .cap file and hit enter. And there we have it, the key in both ASCII, and you can use key after removing the colons. So we cracked the web network even though it was idle. By using the ARP request replay attack, we forced the router to generate new packets with the new IVs and with enough data. We successfully cracked the network key. Simple, right? That's how you can crack web network using the ARP request replay attack. Thanks for watching. See you in the next lesson. Hello friends, welcome back to the ethical hacking course. In the last few videos, we learned how to crack web encryption within a minute, even if the target network was not busy. But now we are going to dive into something more secure, cracking WPA and WPA2. Before we get into the details of cracking, it is important to understand that WPA and WPA2 are very similar. The main key difference, the type of encryption they use to ensure message integrity. WPA used TKIP while WPA2 used CCMP encryption. But don't worry, the methods I will show you will work on both. Security improvements in WPA and WPA2. Now WPA and WPA2 were designed to fix the weakness of WEP. So they are much more secure, and as you might guess, and cracking them is more challenging. But before we talk about how to crack this encryption directly, there is a one feature I want to mention that if misconfigured, make your job easier. This feature is called WPS. WPS stands for Wi-Fi Protected Setup. Was designed to make it easier for devices like printers to connect to a network without needing to enter the password. You might have seen a WPS button on wireless printers and routers. Press the WPS button on the router, then on the device, and they will connect automatically. No password needed. WPS use an 8-digit PIN for authentication, and here is where the vulnerabilities comes in. An 8-digit PIN gives us to a relatively small number of possible combinations to try. If we can guess the PIN, we can recover the actual WPA or WPA key without having to crack the encryption. So, in this case, we are not attacking WPA or WPA2 directly, we are exploiting a weakness in WPS. For this method to work, a few things must be in place. WPS has to be enabled on the network. It should be set to the normal PIN authentication and not push button. If the router uses push button authentication, our attack won't work because the router will ignore any PIN attempts unless the button is pressed. Now, most modern routers either have PBC enabled by default or WPS is completely disabled for security reasons. So this method might not always work, but because WPA and WPA2 are so secure, it's always worth checking if WPS is enabled and misconfigured. If it is, you can try the method I will show you in the next video. And if that fails, we will explore other techniques for cracking WP and WPA2 encryption. That's it for now. In the next video, we will dive deeper into exploiting a WPS and start testing network for vulnerabilities. Make sure to stick around because it's going to get really interesting. Let's move to the next video. Hello everyone, welcome back to the Ethical Hacking. Now that we understand what is WPS and how it can help to recover the password for WPA and WPA2 net. Let's dive into how we can actually perform this attack. I have my Kali machine ready and I have already enabled monitor mode on my wireless adapter. Scanning for networks with WPS enabled. Usually we use AirDump NG to see all nearby networks. But this time we only went to find networks with WPS enabled. For that we will use a tool called WAS. So I will run the command WAS interface and our wireless adapter interface. Then where LAN 0 is my wireless adapter in monitor mode and hit enter. And you will see all the networks that have WPS enabled. Here you can see my target network called GN Access 2.4 GHz. Understanding the output, it's giving us some important details. The vendor of the access point, whether WPS is locked. It says no here, meaning we can attempt to guess the pin. The WPS version, which is version 2 in this case, the signal strength, channel, and BSS ID. If you have forgotten what this terms, If you have forgotten what these terms means, refer back to the earlier lecture on AirDumpNG. But remember, we don't need to worry whether it's WPA or WPA2 because we are targeting the WPS feature. Since our target network used WPS, there is a good chance this attack will work unless it uses push button configuration. In that case, the router would reject all pin attempts unless the button is pressed. The only way to know is to try the attack. I will copy the MAC address of the target network. And now we need to associate with the network using a fake authentication attack. Running the fake authentication attack, I am going to use lplayng for this. And here is the command lplayng fake auth 30-a target ID -h -h for our wireless adapter MAC address. Copy the first 12 digits and paste here. Remove hyphen and replace the colon. And our wireless adapter network interface. This command tells airplane ng to perform a fake authentication attack every 30 seconds to keep the connection alive. Now we are ready to associate with the target network, but I won't execute it just yet. Now first I clear the screen. Running river to brute force the pin. Here is the command river bss id paste target bss id channel and interface and Dido associate. Let me break it down. River is the program. BSS ID provides the target network's MAC address. Channel specify the network channel. Interface specify the wireless adapter and monitor mode. VV stores detailed information. No associate tells River not to associate since we are handling that manually. Now I will hit enter to start River and go back to top terminal and run the fake authentication attack. As you can see, River has successfully recovered the WPA key, which is 12345678990. I can now connect to the network using the password and decrypt any packets being sent. Keep in mind, this method won't work on all routers, but when it does, it is a quick way to gain access. In the next video, we will dive deeper into testing and exploring other attacks and methods. Hello friends, welcome back to the ethical hacking course. In the previous videos, we explored a method to hack Wi-Fi network using WPS. But what if WPS is disabled or configured to use the push button method? Well, in that case, we will have to switch gear and focus on cracking the actual WPA and WPA2 encryption. When WPA and WPA2 encryptions were developed, they were designed to fix the flaws found in web encryption. And they did a pretty good job. Unlike web, in WPA and WPA2, the encryption key are unique, temporary, and much longer. This means the packets sent over the air don't contain any useful information for us, no matter how many we capture. But there is one set of packets that holds the key to this puzzle, the handshake packets. These four packets are exchanged between a client and the router when the client connects to the network. In this lecture, I will show you how to capture these handshake packets, and in the next one, we will see how to use them to crack the WPA or WPA2 keys. First, as always, we will run AirDumpNG to scan all the networks around us. I have done that, and here is my target. It's using WPA2 encryption. We'll copy the MAC address because we will need it soon. Next, let's run aerodump-ng on our target network and store the data in a file, just like we did with web. Here is the command aerodump-ng bss id, paste target network bss id, set channel. Our target is on 6 number channel and save it to one file, right? WPA handshake and our wireless adapter interface 0. Replace with the MAC address of your target with the channel number. This command will monitor our target and store all the data in a file named WPA handshake. Now we just have to wait for a handshake to be captured. This happens when a client connects to the network. So we will wait until a new client connects. But waiting can be boring, right? So let's speed things up. We can use the authentication attack to force the client to disconnect and reconnect. We have done this before. So here is a quick refresher. We will use the aerodump-ng tool to send the authentication packets. Airplay ng the auth code -a paste target bss id -c copy client MAC address and paste here and land 0. Here the auth 4 sends 4 of the authentication packets, just enough to disconnect the client for a moment. Replace with the router's MAC address and with the MAC address of the client you went to target. Once we run the command, when the client reconnects, we should capture the handshake. We got the handshake. Now we can stop aerodump-ng by pressing Ctrl C. This captured handshake is stored in our file WPA handshake. In the next lecture, I will show you how we can use this handshake to get the key for the network. Until then, happy hacking and stay safe. Hello friends, welcome back to the ethical hacking course. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the keys are the handshake packets. In the last lecture, we learned how to capture the handshake and store it in the file. Now the handshake does not contain any information that can help us to recover or recalculate the WPA. The information in it can only be used to check whether a password is valid or not. Therefore, what we are going to do is create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the password one by one and use them with a handshake in order to check whether this password is valid or not. You can actually download ready word list from the internet. But in this lecture, I want to teach you how to create your own word list. In the next lecture, I am going to explain how the word list and the handshake are used in order to recover the password. And we will see how to do that in practice. So in this lecture, we are going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt. If you want to be a penetration tester, you are gonna face a lot of scenario where a wordless attack can become a very handy. Using the tool is very simple. All you have to do is just put the name of the tool and then you specify the minimum number of characters for the password to be generated. Then we are gonna specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase characters. You can put numbers, digits, or you can specify smaller number to make the word list smaller. You can also use the option T, which is optional, to give a pattern. Let's say that you are looking at the person while they are typing their password and you have seen that password will start from an A. So you can tell Crunch that the password will start with an A and then give me all possible combination of password that start with an A. After that, we use the -o option to specify the file name where the password are gonna be stored. We have a small example here that will generate a list of passwords that start from 6 characters to 10 characters and contain this character right here. So it's gonna create a combination of 1, 2, 3, ABC and dollar sign. It's gonna store it in a file called word list. These passwords will always start with A and end with B. The tool actually has a lot of options for other than what we have seen so far. If you just type in man crunch, you will see all the options that you have can set, and you will see all detailed description about all these options. It's actually really good. You can go ahead and spend some time for getting familiar with it. One of the really cool options that I want to highlight is the -p option. The P option tells Kerns to generate passwords that don't have repeating characters. When you specify all lowercase characters as ABCD, it will start by generating password made of 7 times of A and then A 4 times of B. When you do this, Kerns will ignore this type of password and only create password that don't have the repeating character. That will reduce the size of the word list from the number of character raised to the power of length down to factorial of number of character. If you scroll down, you will actually see more example of commands, types of word list of commands and types of word list that will be created. You can have a look at this and get yourself familiar with them. Once you are done looking at them, you can just press Q and you will be out of it. We are gonna run our command here using crunch. I want to generate password with a minimum of 6 characters and a maximum of 8 characters containing combination of ABC and digit 1, 2. Now in here, you can actually keep listing things. You can list characters, uppercase characters, or even symbols if you wanted to. Once you have done listing the character, we are gonna specify the file to save it to call test.txt. The command is very simple. Crunch 6 and 8 ABC and -o for test.txt. It's crunch followed by a minimum length of password, maximum length of password, followed by character we want to use for generating password from, and then -o for specifying where those passwords are going to be stored. As you can see, now it's telling us that its password is generated of 4 megabytes. Now I can open the file by doing cat test.txt. As you can see now, we can see all the generated password containing all possible combination of ABC12. I also want to show you an example using the -t option. I am going to set this for only 6 character using -t, which is for a pattern option. I want it for my password always start with an A while filling all possible combination between A and B. As you can see now, because I have narrowed down possibilities for passwords starting with A and ending with B, while allowing any combination in between using ABC12 results in only 625 possible passwords. Again, if I do cat.txt file, you will see all those generated passwords right here. This tool is really and can be applied useful and can be applied in many scenarios. I highly recommend spending some time with it as well as looking at existing word lists available on the internet. Let's move to the another video. Hello everyone and welcome back to our ethical hacking course. In the previous lectures, we learned that to crack WP and WPA2, we need two main components. First, we need to capture the handshake. Second, we need a word list containing a set of possible passwords that we will try one by one, hoping one of them matches the target network's password. Right now, I have both of these components ready. So we are set to go and crack the password. How AirCrackNG works to do this? We will use AirCrackNG. This tool will unpack the handshake file and extract the useful information. One crucial piece of this information is MIC. MIC stands for Message Integrity Code. This MIC is used by the access point to verify if a password is correct or not. AirCrackNG separate this MIC and set it aside. Then it combines all the other information from the handshake with the first password in the word list to generate a new MIC. It then compares this newly generated MIC with the one extracted from the handshake. If the two MICs match, then we have found the correct password for the network. If they don't match, the tool will move on the next password. in the word list. It keeps repeating this process, taking each password from the word list, combining it with the handshake data, generating a new MIC, and comparing it with the original MIC. If one of the password generates the right MIC, that's the network password. None of them match, then we won't able to get the password using this word list. Importance of good word list. This is why the success of this attack largely depends on the quality and size of your word list. For demonstration, I have a word list test.txt. I have manually added my target password to the end of this list so that when I run it against the handshake, I will find the correct password since it was not included by default. WPA handshake01.cap file in my home directory. You will see both the word list and the handshake file. Running aircrack ng now. We are ready to run aircrack ng. We'll type the command aircrack ng followed by our capture file name WPA handshake01.cap. Since this is a WPA2 network, we have to specify the word list using the -w option like this aircraft WPA handshake01.cap file -w test.txt. Aircrack ng is now going to the word list, testing each word one by one as shown in the diagram. It calculates an MIC based on the information from the handshake and the current password from the word list. If the MIC is correct, it will tell us that we have found the factor affecting speed of the speed of this process depend on your processor and the size of your word list. Larger word list will take longer to process. There are also online services available where you can upload your handshake file and they use word list along with supercomputers to find the password. Success. As you can see, we have successfully found the key. It matches the same key we obtained when exploiting the WPS features. Now we can connect to the network and perform all cool stuff I will be teaching you in the post-connection attack. Alternatively, methods and tips currently, this wordless attack is only practical way to crack WP and WPA2 keys. However, there are methods to speed up the process using GPUs, which are the faster than CPUs. If you have one available, you can also use rainbow tables or pipe your word list directly from Crunch into AircrackNG, avoiding the need to store the word list on your computer. There are even methods to pause your cracking process and resume later without losing your process. But the main idea remains the same. Cracking WPA and WPA2 require a word list attack. That's all for today's lecture. I hope you found this information useful. Stay safe and I will see you in the next video. Hello friends, welcome back to the ethical hacking course. In the previous videos, we have explored various security vulnerabilities in Wi-Fi networks and how hackers can exploit them to crack WP, WPA and WPA2 passwords. We have also discussed different settings to strengthen your network security against these attacks. Today we are going to talk about enabling WPS, Wi-Fi protected setup on a router. So let's get started. First we need to access the setting page of our router. To do that, we need to find the router IP address. Typically, it's the first IP address in your network subnet. Let's find out the IP address of my device by using ifconfig len0 command. Ifconfig len0. As you can see, my device IP address is 192.168.1.36. Now the router's IP address is usually the first address in the same range. So it will be 192.168.1.1. Now let's open our browser and navigate to our router setting page by entering this IP. Open browser and enter router IP 192.168.1.1 and hit enter. You will be prompted to log in with a username and password. By default, it is usually admin for both fields, but it is highly recommended to change this credential later for security reasons. Now I can log in with admin. By entering CAPTCHA, star SCCRR and hit login. Now we are in the router setting page. To enable WPS, go to LAN or Wi-Fi setting. It might vary slightly depending on the router model, but it should be under the similar tab. Here are the WPS settings section. As you can see, it's currently disabled. Let's enable it by uncheck the disable WPS. Now WPS is enabled on your router. You can also see a pin code here, which you can use to connect device securely without entering a full password. In my case, here is my WPS pin 1234567 and 0. If you want to regenerate pin, click here. Or if you want to start PBC, means push button configuration, so click here. One thing to keep in mind, enabling WPS can make your network slightly more vulnerable, as attacker can use tools like revert to crack the WPS pin and get your Wi-Fi password. So if you are not using WPS, it's better to keep it disabled. If you do decide to use WPS, make sure to monitor your network and disable it when not needed. This will minimize the risk of someone exploiting this feature to access your network. And that's it. Enabling WPS on your router is pretty straightforward. Remember to always stay vigilant with your router, with your network setting, and only enable feature you can actually need it. Now I am disabling the WPS and apply changes. Hello everyone. Welcome back to the ethical hacking course. In this section, we are going to dive into something really interesting, post-connection attack. These are the types of attack you can launch after you have connected to a target network. Now, it does not matter what kind of network it is, whether it's Wi-Fi or wired network, or even an Ethernet connection. Once you are in, you have got the keys to the kingdom. And trust me, there is a lot you can do from here. First up, you will be able to gather some really detailed information about every device connected to the same network as you. Think of it as a behind the scene look at what's happening on the network scanning, the all connected device. You can find out things like IP addresses, devices name, and other key detail information that help you understand the network is better. But here is where it gets really interesting. You can also intercept data. That means you can see what other users on the network are sending and receiving over the internet. Get access to user info. That includes sensitive stuff like username, password, and other personal data. It's all out there for you to see. And it does not stop there. Once you are connected, you can even modify data as it's being transmitted. Imagine injecting malicious code into someone's browsing session or manipulating the data they are sending. Pretty powerful stuff, right? Inject malicious code. This gives you the power to perform some pretty advanced attack that can cause all sorts of trouble on the network. So, how do you actually pull this off? You have got two options. You can run this attack on a virtual net adapter, especially if you are working on a Windows machine. Just make sure your virtual Windows and Kali machine are connected to the same net network. Option 1, virtual net network. Option 2, you can run this attack against real computers on your actual Wi-Fi network. In this case, you will need a wireless interface on your Kali machine that's connected to the target Wi-Fi. Option 2, real Wi-Fi network. Throughout this session, I will be showing how to run these attacks in both setups. You will see me target my Wi-Fi network in some cases and use the virtual net in others. So you can get comfortable doing this in different environments. By the end of this session, you will know exactly how to execute these attacks, whether it's on your home network or a virtual setup. So remember, it does not matter how you can get access to the network once you are connected and you are in a control. Stick around because we are about to get into the fun part, running the attacks. Let's move to the next video. Hello friends, welcome back to the Ethical Hacking Course. In today's video, I will be showing you how to download Windows 10 as a virtual machine for VMware directly from the official Microsoft website. If you are looking to test or use Windows 10 in a virtual environment, this is the easiest way to do it. So let's jump right into it. First, let's head over to your browser and open the official Microsoft website. and I will guide you step by step. Step 1. Search, download Windows 10 disk image ISO file in your search engine and open the link now. Once you land on the correct page, you will see a section titled Create Windows 10 Installation Media and press Download Now button. After downloading, click to run it. It takes us several times. After getting this page, scroll down and accept and wait for next page and select second option Create Installation Media, USB flash drive, DVD or ISO file for another PC and press next and you can see a language, edition and architecture. You can also change this from here according to your system requirement and press next and download ISO file for your virtual machine. I have already installed ISO file. So after successfully download ISO file, create a new virtual machine. Next, and browse your path here of your ISO file and open it and configure it. I have already configured my Windows 10. Let's move to the next lesson. Hello friends, welcome back to the ethical hacking course. Today we are diving into one of the most crucial steps in hacking, information gathering. You can break into a system if you don't know enough information about it, right? That's where information gathering tools come into play. And in this video, we are going to learn how to use one of the simplest yet most effective tools, Net Discover. Imagine you are connected to a network and your target is one of the devices on that network. What is your first step? Figure out who is on the network with you. You need to gather details like IP addresses, MAC addresses, and other device specific info. Once you have that, you can use it to plan your next move, whether that's running attacks or digging for more intel. Now, there are plenty of tools to help with this, like NetDiscover and Nmap. For today's video, we are going to start with NetDiscover, which is perfect for quickly mapping out a network and seeing all the connected devices. In the next video, I will show you how to use Nmap for more detailed information. Alright, I have got my Kali Linux terminal open. First, I will run the command ifconfig to check my network interface. As you can see, I have an ETH0 interface with an IP address. Here is my IP address. This is because I am using a net network in a virtual machine. But the process works the same whether you are on a virtual or a real network. This is ETH0 interface represents my connection to the network. Even though it's virtual, the Kali machine thinks it's connected to a real Ethernet network. I have also got a virtual window machine on the same net network, simulating my target. Now let's run NetDiscover to find out what devices are connected to the same network. The command is simple, NetDiscover and R. The R specifies the range of IPs I went to search. My IP is 192.168.73.131. So I can only scan IPs in the same subnet, which is range from 192.168.73.1 to 192.168.73.254. Now enter your network first IP address 192.168.73.1 according to your IP address. Instead of man Instead of manually typing the entire range, I will just use 24 at the end of the IP address and NetDiscover will handle the rest, scanning from 192.168.73.1 to 192.168.73.254. And there you go. NetDiscover shows me all the connected devices, their IP addresses, MAC addresses, and it even tries to guess the vendor based on the MAC addresses. You can press Q to exit the program. Simple, right? This works just as well for real networks, including Wi-Fi if you have got a right setup. Speaking of Wi-Fi, let's move to the wireless network. You will need an external wireless adapter if you are running Kali in a virtual machine, as the built-in Wi-Fi card won't be accessible. Now that I have connected to the adapter and configure it, I will run if configure again, and there it is, LAN 0. This is my Kali machine is now connected to a Wi-Fi network. This one, and we can scan for devices. Let's run Net Discover again, but this time with my new IP 192.168.1.38, and I will set the range to 192.168.1.1 and 24 to cover the entire subnet. Net Discover R. Enter your network first range IP 192.168.1.1 and 24 and hit enter. Whether you can see the devices list not shows perfectly because we don't turn off the net adapter. So first we need to turn off or disconnect the net adapter. Then run again. As you can see, it's discovering all the connected devices on the Wi-Fi network. Same command, different network, same reliable result. How easy it is to use Net Discover to gather information about devices on the network. Whether you are working in a virtual environment or a real network, the process remains the same. But you need to turn off or disconnect the net adapter from here, from VM section, and remove old device and turn off network adapter and turn off net adapter. So in the next video, we will step it up a notch with Nmap and learn how to get more detailed information about each device. Thanks for watching and see you in the next video. Hello friends, welcome back to the ethical hacking course. In the last video, we explored how to use NetDiscover to map out all the devices connected to our network, see their MAC addresses, and maybe even get their vendor detail. Today, we are taking things to the next level with Nmap. Nmap is an incredible, powerful tool for network scanning. While it's a bit slower than a NetDiscover, the amounts of information it gives you about a target is on a whole different level. Nmap does not just show you who is connected, it tells you what ports are open, what services are running on those ports, the computer's name, and even the operating system. You will be able to discover everything from connected clients to bypassing certain security measures, including firewalls. Now, Nmap is a huge tool. There are books and entire courses just on Nmap. But don't worry, in today's video, we will focus on the basics. I will show you how to use it to discover connected clients and gather useful information about them. Instead of using the command line version of Nmap, we are going to use GenMap, the graphical user interface of Nmap. To launch GenMap, just type GenMap in the terminal or find it in your application menu. As you can see, GenMap has a simple interface. As you can see, GenMap has a simple interface. The first thing you will notice is the target input box. This is where you enter your target. It could be an IP address for a computer, a server, or even a website server's IP. Now, just like in the previous video with NetDiscover, we can also scan a range of IPs. GenMap will scan the entire range, discover all the live IPs on the network, and display details about them. I am connected to my wireless network right now, so I will set the range for this network, which is 192.168.1.1 and 24. At the bottom, you can see actual nmap command that will run when I hit scan, and select the ping scan and hit the scan button. If you know custom nmap command, you can paste it here too. Nmap also has some ready to use profiles if you don't know much about nmap commands. In today's video, we will use a few of these profiles and see how they differ in speed and the information they collect. Let's start with the ping scan. This is the quickest scan. It ping all possible IPs in the range, and any device that responds is recorded, showing that it's connected. Keep in mind, So not all devices respond to ping requests. So the list might not include every connected device. Once the scan is done, we can see a list of devices along with their MAC address and vendors. For example, I can see one device with 198.168.1.1 is a device. This is my router. Another device is 192.168.1.40 is a Dell laptop. And as you can see, every connected device to the network. Now let's try the quick scan. It takes a bit more time than the ping scan, but it gives a more detailed information like open ports on each device. For example, my router port 80 is open. This port is used to accessing router setting through a web interface. We also see that the device has port 22 open, which is for SSH, which, which is for SSH, a service used for remote access. As we go through the devices, we can see which port are open and what service are running on them. This is crucial because these open ports could be potential point of entry, especially when we move to the next session on gaining access. In the next video, we will dive deeper into information gathering and see how it's helped us during hacking. For example, we will use the data we collected today to hack into an device connected to the same network. Thanks for watching, and I will see you in the next video. Hello friends, welcome back to the ethical hacking course. We took a brief introduction of ZenMap and how it can help us to gather useful information about devices on the network. Today, we are going to build on that by exploring a more advanced scan, the Quick Scan Plus. This scan takes the basic quick scan to the next level. While it might take a bit more time, it gives us a lot more valuable information that can really help us in a later step, especially when we get into gaining access to the device. What does the Quick Scan Plus do differently? Well, for starter, it not only detects open ports but also tells us the operating system running on the discovered devices, the type of device, whether it's a phone, laptop, router, or something else, version running on those open ports. For example, in the previous scan, we might have found that port 80 was open, but we didn't know what software was running on it or its version. Now with the Quick Scan Plus, we can see that kind of detailed information. Why is this information important? This level of detail is super helpful, especially later on when we start exploiting vulnerabilities. Knowing the exact version of a program allows us to search for a known weakness, making it easier to gain access to vulnerable systems. The device 192.168.1.40. Let's take a look at one of the device discovered in the scan. Let's take a look at one of the device discovered in the scan. This is computer device, and in our last scan, we know that port 22 was open, but we didn't know what version of SSH was running. Now we can see it's running Open SSH 9.6 PL ABN3 Protocol 2.0. With this information, we can quickly look up known vulnerabilities for this version, which could be our way in when we move to the gaining access section. We also learn more about the device itself. It's a PC running on Windows. This detailed information can be critical when trying to decide what kind of attack we might use later. Now, thanks to the Quick Scan Plus, we can see the port 80 was running on Apache HTTPD. We can see that port 80 is running Apache HTTPD version 0.93.50 on Linux. This gives us specific detail that we can use to look up known exploits. Another cool feature is the ability to browse devices based on services. For example, we can look at all devices running HTTP service or SSH service by clicking on the respective tabs. It's a greater way to filter device if we are targeting a specific service. We have a computer on the network, the same device from earlier, running OpenSSH on port 22. Now device don't normally have SSH installed unless they have configured. Since this computer has SSH service running, we know it's configured. By default, The SSH password on user is Kali unless the user has changed it. Which most don't. So let's try to connect to this computer using the default password, and I will open the terminal. Type SSH Kali @192.168.1.40 and hit enter. When it asks for password, and I will type Kali. Now I am in as the root user. I have full control over this computer just by using this information we gathered. No complex hacking was needed here. It's just the power of information gathering. So you can see the quick scan plus can give us a ton of useful information that we can use later when trying to gaining access to the device. In upcoming videos, we will dive deeper into this topic and show you how to use this information to exploit vulnerabilities and gain full control over the device. Make sure to try out the other scan profiles on GenMap and keep practicing. And if you want to go even deeper, I recommend checking out the Nmap book. It's fantastic resource. Thanks for watching, and I will see you in the next video where we will continue exploring the ethical hacking. Stay tuned. Hello friends, welcome back to the ethical hacking course. In today's video, we will begin exploring one of the most common types of cyber attacks, man-in-the-middle attacks, often called MITM. These attacks allow hackers to intercept communication between two devices, putting them in a powerful position where they can steal sensitive information or alter it. Let's dive into how these attacks work and why they are so dangerous. Normally, communication between two devices, like your phone and a website, happens directly. The information is sent from one device to other device without interruption. In a man-in-the-middle attack, a hacker sneaks into the middle of this connection. Now every bit of information that passes between the devices is interrupted by the hacker. They can read, steal, and even change the data without the two devices ever knowing. One of the ways hackers can carry out a man-in-the-middle attack is through something called ARP spoofing. In ARP spoofing, the hacker tricks both devices into sending all their data through the hacker's computer instead of directly to each other. So, instead of data flowing directly between the devices, the information is intercepted by the hacker first. This means any passwords, private messages, or sensitive data shared between the devices will be passed to the hacker system. To understand how ARP spoofing works, we first need to understand what is ARP is. ARP stands for Address Resolution Protocol. ARP is a simple protocol used to connect IP addresses to MAC addresses in a local network. The IP address is like your home address. It tells other devices where your device is on the network. The MAC address on the other hand is like your device's personal identification number, which is used to send and receive data. Here is an example. In this network, we have four devices A, B, C, and D, and a router. Each device has both an IP address and MAC address. Let's say device A needs to communicate with device C. Device A knows the IP address of device C, but it needs the MAC address in order to send data. Here is how device A gets the MAC address. It sends out an ARP request, which is broadcast message to the entire network. The message says who has this IP address. All the devices on the network receive the request, but only device C responds, saying, I have that IP address and here is my MAC address. Now device A knows device C's MAC address and they can communicate directly. This process is happening all the time in the network to help device communicate smoothly. So, how does a hacker exploit this? ARP is a simple protocol with a major flaw. It does not verify if the response it receives is from the correct device. A hacker can take advantage of this by sending fake ARP response to trick both the router and the target device. The hacker sends an ARP response to the router pretending to be the victim's device and another ARP response to the victim pretending to be the router. This trick both the router and the victim into believing that the hacker is the device they are trying to communicate with. As a result, all the data from the victim is routed through the hacker's computer before it reaches the router, and the responses from the router are also sent to the hacker system before they reach the victim. Now that the hacker is in the middle of the communication, they can see all the data flowing between the devices. This could include sensitive information like usernames, password, and financial data. Even worse, the hackers can modify the data being sent. For example, they can change the content of a message, redirect you to a fake website, or drop the connection entirely, causing a denial of service attack, which is known as DOS attack. So, why is the ARP so vulnerable? There are two main reasons. First, device accept ARP responses even if they didn't send a request. This means a hacker can send a fake ARP message to a device that has not asked for them. Second, neither the router nor the target device verifies the authenticity of the ARP response. This makes it easy for hackers to impersonate other devices on the network. Let's look at the practical example. Imagine you are connected to a Wi-Fi network in a coffee shop. If a hacker is also connected to the same network, they can launch an ARP spoofing attack. The hacker sends ARP response to your device pretending to be the router and send a fake ARP response to the router pretending to be your device. Now every bit of data you send, whether it's browsing website, sending emails or logging into your bank account, passes to the hackers first. In summary, ARP spoofing is a powerful technique that hackers use to intercept and control communication between devices. By exploiting this weakness in ARP, they can steal sensitive information or disrupt the communication entirely. The best way to protect yourself from ARP spoofing and man-in-the-middle attack is to use encrypted connections such as HTTPS and avoid using untrusted networks. Stay tuned for more videos where we will explore how to defend against these attacks, and thanks for watching. See you in the next video. Hello friends, welcome back to the Ethical Hacking course. Now that we have a solid understanding of how ARP spoofing works, let's move forward and see how we can execute this attack to manipulate the flow of data, rewriting it to our own device. By doing this, we will be able to intercept everything sent to and from the target computer, including sensitive information like username, password, and more. There are several tools available to carry out an ARP spoofing attack. However, in today's session, I will be walking you through a simple yet reliable tool called ARP spoof. In upcoming lectures, we will switch to a more feature-rich tool called BetterCap. The reason I am introducing ARP spoof here is that it's extremely easy to use, but also very dependable. It's available across multiple operating systems including iOS and Android. So once you understand how to use it, you can deploy it on virtually in any system. With ARP spoof, we can redirect the flow of data to pass to our computer. After redirecting the data, you can then use other tools like Wireshark or Packet Sniffer to analyze the data, which we'll discuss further in this course. Let's start using ARP spoof. First, open your terminal and type ARP to see gateway IP and MAC address on ETH0. Then type ARP spoof I ETH0. The I specifies the network interface connected to the target network. In my case, it's ETH0. In my case, it's ETH0. If you are unsure of your interface, run the if config command and you will see the one connected ETH0. For this demo, I will be using this attack on my virtual network. You can also run this on Wi-Fi networks, which I will cover later. For now, I will recommend testing it on virtual network as I am doing here. Next, let's specify the target IP address using the T. My target IP is 192.168.73.134. Now I'll copy that and paste here. You will also need to provide the gateway IP address, which is 192.168.73.2. So I'll write here 192.168.73.2. This will trick the target into believing that I am the router. Now I clear the screen and also run the same command ARP spoof I ETH0. Now you need to enter gateway IP address 192.168.73. Now enter your target victim IP address and enter 6.3. Now enter your target IP address, which is 192.168.73.134. We will run the ARP spoof command twice. First to fool the victim into thinking we are the router, and second to trick the router into believing we are the victim. Now I will run the command here and here. Remember, this attack works on both wired and wireless networks. Here I am using a virtual wired network, but the same approach applies to Wi-Fi networks. If you want to target a wireless network, you need to connect a wireless adapter to your Kali machine and follow the same process. After executing the commands, go to the target machine and run ARPA. ARPA. You will notice the MAC address of the router has changed to the match the MAC address of my Kali machine. You can also verify with old MAC address. Now, every request from the target will send to the my machine first. Now I am going to Kali machine. Since my machine is not a router, it won't forward the packets unless we enable port forwarding. To do this, use the following command: echo 1 greater than drop slash date IPv4 IP underscore forward. With port forwarding enabled, the target machine will still have internet access, but all the requests and response will pass to our computer first. As shown in the diagram, the target's data flow to our machine before reaching the router. This allows us to position ourselves as the man in the middle. Once we are in the middle, we can inject code into the target's browser, still sensitive data like username and password, monitor all communication, replace legitimate file with malicious one, and much more. That's a quick demo of how to use ARP spoof for ARP spoofing attacks. In the next lesson, we will explore more advanced tools and techniques. Stay tuned. In our previous lesson, we learned about ARP spoofing and how we can use a tool called ARP spoof to intercept connection within our network. ARP spoof is a simple, reliable tool, and it's available across various operating systems. But now, in this and the upcoming lessons, we are moving on the more advanced tool called BetterCap, like ARP spoof. BetterCap allows us to perform ARP spoofing attacks, but it offers much more. With BetterCap, we can capture and analyze network data, see usernames and passwords, bypass HTTPS, potentially bypass HSTS, perform DNS spoofing, inject code into web pages, and so much more. I will show you how to run BetterCap and give a quick overview how to use it. We will dive deeper into the tool in upcoming lessons. To run BetterCap, all you need to do is type its name in the terminal, BetterCap, and if you want more information about its command and uses, you can type BetterCap help. We will be using this tool a lot throughout this course, and you will learn more as we go along. Starting BetterCap, let's clear the screen and run the command. I will type BetterCap iFace ETH0. Here, I am specifying the network interface with the iFace option. In my case, the network interface is ETH0. You can find your interface by typing ifconfig on your terminal. Ifconfig, you can see ETH0. Now I close the screen and hit the enter. You will be inside BetterCap and you will see a new prompt where you can start using its command. To get a list of all available commands, simply type help. Exploring BetterCap module. BetterCap operates using modules which allow you to perform different network attacks and data analysis. Let's take a look at two important modules today, NetProbe and NetRecon. I am going to type help NetProbe. This command gives a description of the net.probe module, which continuously sends UDP packets to discover devices connected to the same network. You can turn it on with the command net.probe on. Similarly, to turn it off, you have to use net.probe off. Now entering the help command, and you can see the net.probe is running now. Now discovering connected clients once you turn it on net.probe. It will automatically start discovering all connected devices on the network. For example, it might show the IP address of a Windows machine that's connected to the same network. When net.probe starts, it also triggers net.recon automatically. The net.recon module monitors the ARP cache and adds discovered IPs to a list, which we can target later. To see all the connected clients, you can use the command net.show. Net.show. This will give you a list of all clients connected to your network, along with their IP addresses and MAC addresses. It will even try to identify the hardware manufacturer of each device. That's it for today's overview. We have covered how to get help for BetterCap module, how to run them, and how to analyze the results. In the next lecture, I will show you how to use BetterCap to launch an ARP spoofing attack to intercept data like usernames and passwords flowing through the network. Stay tuned as we dive deeper into these powerful capabilities. Thank you for watching and see you in the next lesson. In this video, I am going to show you how to perform ARP spoofing attack using a powerful tool called BetterCap. With this, we can place our computer right in the middle of the connection between a target device and the router, intercepting the data being exchanged. Not only that, but I will also show you how to read this intercepted data, things like URLs, websites, the target widgets, and even sensitive information like username and passwords. Sound interesting, right? Let's dive into it. Alright, the first thing we need to do is become the man in the middle. We can do this using BetterCap's ARP spoofing module. If I scroll up in the help menu, you can see there are a module called ARP spoof. To understand how this works and what options can modify, let's type help ARP spoof. Help ARP spoof. As you can see, there are a few commands to remember. For instance, you can turn on ARP spoofing on by typing ARP spoof on. Similarly, you can cut off the target's internet connection by typing ARP.ban on. But we won't be doing that here. To be disable this feature, you can simply use arpspoof.off or arp.ban off. In the last video, I briefly mentioned that we can adjust parameter for these modules, but today I am going to BetterCap makes this simple by providing the option name, description, and default value. Let's take the option ARP spoof full duplex as an example. Let's take the option ARP spoof full duplex as an example. This option, when set to true, will spoof both the router and the target device. By default, it's set to false, which means we only spoof the target machine. I will change it to true because we want to control both sides of the connection. So both the router and the target will think our machine is the other one. To do this, we simply type step ARP spoof full duplex true. Once you hit enter, the change is made and no errors when it's executed successfully. Now we need to tell BetterCap which device is to target. There is an option called ARP spoof targets where we can specify the target IP. I am going to use the IP of my target device, which is my Windows Virtual Machine IP. Now check the Windows Virtual Machine's IP. You can use ARP if for checking IP address of Windows machine. Again, I will use the set command like before. Set ARP spoof. Set ARP spoof targets 192.168.73.134. Here is my Windows Virtual Machine's IP address and hit enter. No errors, looks good. Alright, we are ready to start the attack according to the health menu. All we need to do now is turn on the ARP spoof module with the command ARP spoof on. Let's run that. The error message shows because my ARP spoof is already running. So I don't need to turn on ARP spoof because I have already running. So if we check by typing help again, you can see here ARP spoof is now active. Let's verify that everything working correctly. I will go over my Windows machine and run the command ARP A. As you can see, the router's MAC address has been replaced with the MAC address of my Kali machine. This means that any data the Windows machine wants to send to the router is now sent to our machine. Similarly, because we enabled full duplex, any responses from the router internet for the Windows machine are also sent to our Kali machine. So we have successfully placed our computer in the middle of the connection between the target device and the router. This means that every bit of data, whether it's usernames, passwords, or web activity, will pass to our machine, allowing us to read, modify, or drop it. In the next video, I will walk you through how to analyze this intercepted data. Stay tuned. That's it for now. Let's move to the another video. In the last lecture, we talked about using BetterCap to execute an ARP spoofing attack and place ourselves in the middle of the connection between a target computer and the access point. This allows us to intercept and analyze all the data flowing between them. Now that we have placed ourselves in the middle, all of the internet traffic, whether it's URLs, images, videos, or even passwords, is passing through our computer. Today we are going to learn how to capture and analyze this traffic. So our computer is already in the middle of the connection and data is flowing through us. To capture this data, we will use the NetSnip module in the BetterCap. This module automatically captures, analyzes, and display interesting data. To start, you can type help netsnip help netsnip to see the available options. But for now, we will keep things simple and run it with default setting by typing snip snip on. This command will start capturing all the traffic flowing through our computer. Now that we have started the capture process, let's move to our target machine. For this demo, we will use a Windows computer and I will open the browser and generate some traffic to see if BetterCap capture it. For this example, we will visit a website called worldweb.com, which is not using HTTPS, making it easier for us to capture data. Remember, what we are doing right now won't work on HTTPS protected sites. But don't worry, we will cover how to bypass HTTPS later in this course. Let's go back to the Kali machine where BetterCap is running. As you can see, every request made by the Windows machine has been captured, including requests to the Google and the site oneweb.com. We can even see files loaded from the site like images or style sheets. As you can see, the visited file, as you can see, the visited site where our target machine was visited. Next, let's test capturing some login credentials. I will go back to worldweb.com and open the link and enter username. I will try logging in with the username admin and password 123456789 and 0. Once login, I will go back to the my Kali machine. If we scroll through the captured data, you can see the exact login request sent to the site, including the username and password in plain text. As you can see, anything the target device sends or receives can be captured by our Kali machine using BetterCap, whether it's a computer or a phone, and whether it's connected via Wi-Fi or wired network. In the next session, we will dive deeper into HTTPS and talk about the method to bypass it. Stay tuned and thanks for watching. In our previous videos, we explored how to use BetterCap to discover all the devices on the network, launch an ARP spoofing attack, and capture data including usernames, passwords, and much more. But each time we did this, we had to manually run several commands. For example, we had to start by enabling the net.probe module, configure the ARP spoofing settings, and then run the sniffing module. But it requires multiple steps each time. If you are like me and you don't want to type all those commands every time, there are much simpler solution is Caplet. So what exactly is Caplet? It's just a text file that contains all the commands we want to run in BetterCap. Instead of entering them one by one, we can create a caplet to do it all automatically. Let me show you how it works. We are going to start by opening an text editor. The first command we always use is netprobe.on. So I copy that and paste here. This command enables the network recognition module to discover all the devices on the network. We set up the ARP spoofing module. We do this by setting it to full duplex mode with the command set ARP spoof full duplex true. I will copy that and paste here. Next, we set up the ARP spoofing module. After that, we need to specify the target IP, one you are targeting. Here, make sure you replace the IP with the one you are targeting. After that, we need to specify the target IP, which is that ARP spoof targets 192.168.73.174. Here, make sure you replace the IP with the one you are targeting. So I'll copy that and paste here. Finally, we add the commands ARP spoof on to activate the ARP spoofing net snip on to start the sniffer module. Once you have all the commands ready, save the file with the .cap. Once you have all the commands ready, save the file with the .cap extension. Now I save the file. In my case, I will call it spoofing.cap file. Select the root, save it. Now, instead of manually entering each command, we can run BetterCap with the caplet file. To do this, we just use the caplet option followed by the name of the file. For example, now I clear the screen and exit and write command BetterCap iface eth0 caplet and our file name spoofing.cap. This will automatically run all the commands in the caplet file. Let me show you how it works. Now I can check the services. You can see the ARP spoof, NetPro, NetRecon, NetSnip are active. I'll check the ARP table on my target machine before running the caplet. This will automatically run all the commands in the caplet file. Let me show you how it works. I'll check the ARP table on my target machine before running the caplet. I check the ARP. As you can see, the MAC address for the router is set to its real value. Now when I run the caplet, now I run the caplet and run ARPA into target machine, the ARP table updates and you can see that the MAC address of the router has been changed to that of my Kali machine, meaning we successfully performed the ARP spoofing attack. Just to confirm it's working, let's go back to our test website and I will log in again with the username and password. And log in. Now let's move to our Kali machine. And as you can see, we are able to intercept the login detail right here on your terminal and we get the username and the password. So what did we just do? We used a caplet to automate the entire process of ARP spoofing and data sniffing. This is super handy if you are going to perform these attacks frequently. Instead of typing everything out each time, just run the caplet and let BetterCap handle the rest. That's it for this tutorial. In the next video, we will dive deeper into caplets and how to create more complex ones to automate other tasks in BetterCap. Thanks for watching. See you in the next video. Hello everyone. In today's video, we are going to dive into how we can bypass the security of HTTPS and downgrade it to HTTP, enabling us to capture sensitive information like login credentials and passwords. Remember, this is for educational purpose only. So, far we have focused on how man-in-the-middle attack work on HTTP websites. The reason why this is possible because HTTP send data in plain text, which means anyone intercepting it can easily read and even modify the content. However, most websites now use HTTPS, which secure data by encrypting it, making it unreadable to anyone trying to intercept it. HTTPS use SSL or TSL protocol to do this, making it extremely difficult for attackers to break through. Since breaking HTTPS encryption is complicated, the easiest way around it by downgrading the connection from HTTPS to HTTP. This allows as the man in the middle to intercept and read the data in the plain text. BetterCap makes this process much easier for us. There is a caplet in BetterCap specially designed for this, but it does not replace all HTTPS links properly. That's why I have customized this caplet to work as expected, and I have included it for you in the resource. Now let's set it up. First, download the HSTSH hijack.zip file from the resource and extract it. Once extracted, we need to move the caplet file to BetterCap's default location, where it stores caplet. Now I'll copy the folder, copy, and open path by pressing Ctrl L and navigate to a caplet file to BetterCap's default location. So type user local share BetterCap caplets. As you can see, HSTSL hijack folder. It is a default folder. Now I will delete the folder and delete the existing buggy caplet and replace it to our customized one. So I will delete it and paste here our customized caplet. And before we start using the caplet, we also need to modify our sniffer caplet from the previous lesson. This caplet run the ARP spoofing and sniffing commands, open it in a lib page, and add the following line set set.sniff.local true and save it. This ensures BetterCap will capture all the data even if it thinks the traffic is local. If we don't do this, BetterCap might think the intercepted data belongs to our computer and ignore it. Once we have made this modification, you are ready to go. In the next video, I will walk you through how to use this caplet to downgrade HTTPS connection to HTTP. And we will see how we can sniff sensitive data like usernames, passwords, and URLs. Thanks for watching. In the next video, we will demonstrate the live attack. So stay tuned and see you in the next video. Hello everyone. Now that we have covered the theory behind bypassing HTTPS and have our caplet set up in the correct path, it's time to get hands-on. Today we will be using BetterCap to downgrade HTTPS to HTTP and demonstrate how we can capture sensitive information like password from websites that default to HTTPS. So let's jump right into the terminal. I will be running BetterCap just as we have done before. We will use the IFS argument to specify our network interface and then use the caplet argument to load the spoof caplet. This is the same caplet we built earlier and it will execute the ARP spoofing and sniffer command automatically. As you can see, everything is running properly. If I type help, we will see that all the relevant modules like ARP spoof, sniffer, recon, and probe are active. This is exactly what we want. Now, the next step is to run HSTS bypass caplet we just placed into the BetterCap directory. If you want to see all the available caplets in BetterCap, you can simply type caplets.show. Here, as you can see, here is our caplet. This gives you a list of all caplets along with their path. We are focusing on HSTS hijack caplet. It's located here in the BetterCap directory. To run any of these caplets, all you have to do is start typing its name and you can use tab for auto completion. Now that we have run the caplet without any errors, it's time to test it out. Let's head over to our target machine and try to browse some HTTPS website. Here is my target machine. Before starting, it's always good idea to clear your browsing data to avoid loading cache version of the website. Now, open the browser and I will quickly do that using Control, Shift and Delete and select all items to clear everything. Let's visit, let's visit demo page fire.net, which typically use HTTPS. If you look at the top of the browser, you will notice it's loading over HTTP instead of HTTPS. Exactly what we want. Let's enter some login details and I will use s3cloudhub.in and 123456789 as the password. Although we get an error on the page. Let's check our Kali machine to see if we capture any data. As expected, we have intercepted the login request and here is the username and passwords. And here is the username and password. However, this method won't work on websites like Facebook or Twitter that use HSTS. That's because Facebook uses HSTS, which is harder to bypass. In the next video, we will dive deeper into what HSTS is and why it's more challenging, and how we can partially bypass it to still capture username and password from websites that use it. That's it for today's demonstration, and see you in the next one.
Welcome back. In our previous lecture, we explored how to downgrade HTTPS website to HTTP, which allows us to see all the data the user was sending because HTTP traffic is in plain text. We could view usernames, passwords, and everything else that the user did. However, I also show you that this method does not work against websites like Facebook, Twitter, which use something called HSTS, HTTP Strict Transport Security. Let me explain why that happens and how we can bypass it. So, what is HSTS? Well, modern browsers like Chrome and Firefox come with a built-in list of websites that should always be loaded over HTTPS. Even if we try to send back an HTTP version of the site, the browser ignores it. This list includes popular websites like Facebook, Twitter, and others. And once we become the man in the middle, there is nothing we can do because the browser locally checked this list. The browser does not even send a request over HTTP. It directly uses HTTPS and only accepts HTTPS response for these websites. So, how do we can bypass this? The only practical solution is to trick the browser into thinking it's loading a different website. We do this by replacing HTTPS link with similar looking but slightly different domains. For example, instead of facebook.com, we can replace it with facebook.com. I know this seems obvious when you hear it, but visually the letters R and N together look like M in the browser's URL bar. Another example is replacing twitter.com with twitter.com using just one T instead of two. This might sound confusing right now, but don't worry, I will show you exactly how this works in practice. I have my Kali machine ready and we will be using an HSTS hijacking caplet with better cap. In the previous lecture, I show you how to downgrade and place this caplet in the right directory. Here how it's works. The caplet is stored in user share better cap caplets HSTS hijack and is named HSTS hijack.cap. Right click and open it in a text editor. You will see pre-configured targets and replacements. Target are the website using HSTS like twitter.com and .twitter.com. The wildcard means it's target any subdomain of Twitter. Replacements specify the spoofed domains. For example, twitter.com becomes twitter.con. You can modify this replacement if you want. For instance, you could use twitter.com with a single T instead of con. It's flexible. Now, it's crucial to ensure that the DNS spoof domains are set exactly the same as the replacements. I literally copy and paste them to avoid mistakes. Once everything is configured, we are ready to run the attack. Now I close it and open terminal. Once everything is configured, we are ready to run the attack. The process is almost identical to what we did in the previous lecture with ARP spoofing and running BetterCap. Here is a step-by-step breakdown. Run BetterCap with the command we used last time. And load the HSTS hijack caplet by typing HS and pressing tab to autocomplete. Once it's running, switch to the target machine. Let's use a Linux machine running the latest version of browser. Now, on the target machine, I am going to open browser. And first of all, we clear the browsing data by pressing Ctrl+Shift+Delete and clear all. Now, I enter www.linkedin.com. As you can see, the website loads in HTTP and I click the signing button and try to sign in s3cloud@gmail.com and password 12345678990. Now I press the signing button. Let's move to our Kali machine and check what we can capture it. As you can see, we successfully captured the username and password. This method allows us to bypass HSTS, but it's important to note that it only works under specific conditions. The user has to first go to the website that does not use HSTS before visiting the target website. So, while this is a clever trick, it's not a full solution for bypassing HTTPS protections, but it's still very effective in the right circumstances. In the next lecture, we will dive deeper into other techniques like JavaScript injection to extend this attack. Thanks for watching and I will see you in the next lecture. Welcome to this lecture. Today we are diving into DNS spoofing, what it is and how you can perform this attack using BetterCap. Let's get started. First, let's quick understand DNS. Think of DNS as the internet's phone book. When you type a website's name like google.com into your browser, DNS converts that name into an IP address, the unique location of the server where the website's files are stored. For example, when you request google.com, your browser talks to a DNS server which returns Google's IP address, allowing your browser to load the site, which returns Google's IP address, allowing your browser to load the site. But what happens if we are the man in the middle? Instead of letting the request go straight to the DNS server, we intercept it first. And now, instead of returning the real IP of the website, we can respond with any IP we want. That means we can redirect user to fake websites, backdoor pages, or even hijacking software updates. We will cover more advanced examples in future lectures, but for now, let's focus on running a basic DNS spoofing attack using BetterCap. In this demo, we will redirect requests from a specific website to our own local web server. Now let's move to the Kali machine. Before running BetterCap, we need to set up a web server on Kali Linux. Kali comes with Apache 2, a built-in web server. So let's start that with the command. Type command service Apache 2 start. If there are no errors, it means the web server is running. To check this, we need to find the IP address of our Kali machine. We will use the ifconfig command. Our IP is 192.168.73.131. Now, when I type this IP into a browser, you will see the default page of the Apache web server. I'll copy that and open browser and paste our IP address. and hit enter. You will see the default page of the Apache web server. Now open the file where this index files are stored. So open the file and press Ctrl L and type where www.html and enter. The main file loaded by default is index.html. Let's quickly edit it to display a name. As you can see, here is the code of index.html, and I will remove it and type s3 cloud and save it. Now when I refresh the page, you can see the name of S3 Cloud Hub has appeared. This is what we will redirect our target to during the attack. Let's use a target machine for this demo. When we visit a website, for example s3cloudhub.in, you will see the actual website load as expected. Now let's see how we can intercept and modify this using BetterCap. We will start BetterCap. Now let's see how we can intercept and modify this using BetterCap. So let's move to our Kali machine, close it. We will start BetterCap just like we have done in previous demonstration. With the spoof caplet loaded, we can intercept and modify the data as it passes through our machine. So run the BetterCap and type help. As you can see, DNS spoof is now not running. The module we need is DNS spoof. Let's check the option by typing help DNS spoof. Help DNS spoof. The first option we need to set is DNS spoof address, which tells BetterCap where to redirect the target. By default, it's set to our machine's IP address, so we will leave it. Next, we enable DNSspoof.all so that BetterCap respond to all DNS requests. We do this by typing set DNS spoof all true and hit enter. Then we need to specify the domains we want to spoof. In this case, we will targeting s3cloudhub.in and all its subdomain using a wildcard. So I will type set DNS spoof domains s3cloudhub.in and hit enter. Once everything is set, we start the DNS spoofing module by typing DNS spoof on. As you can see, BetterCap is now actively spoofing DNS requests for S3 Cloud Hub and redirecting them to our IP address. Let's head back to our target machine and test it. Remember, if you have recently visited the site, you might need to clear your browsing data for the changes to take effect. Now when the target visit S3 Cloud Hub.in, they are redirected to our local website with the name of S3 Cloud Hub. The attack is successful. This DNS spoofing attack can work on most websites, even those using HTTPS. But there are limitations. For example, sites using HSTS won't be vulnerable since the browser maintains a local list that forces HTTPS connections. So we have shown a simple text message S3 Cloud Hub, and DNS spoofing has many real-world applications. You could redirect users to phishing pages, fake login screens, or even deliver backdoor software updates. We will explore these advanced uses in future lessons. Thanks for watching. Stay tuned for more lessons on ethical hacking. Hello everyone and welcome back. So far we have explored some powerful techniques once we become the man in the middle. We have seen how to monitor everything that happens on the target device. Websites, usernames, passwords, images, everything they load on that browser. We have also seen how to redirect the target to different websites using a DNS spoofing. But there is another existing capability that we will explore today. modifying web pages as they load in the target's browser. Since we are intercepting all data as it passes, we can inject our own code into these web pages and make the browser execute. Now, HTML controls the structure of the page, but it's JavaScript that brings real power, allowing us to manipulate the entire page dynamically. We can add, remove, or modify elements on the pages, replace links, and even hook the target's browser to other exploitation frameworks. In this demo, I will show you how to inject a simple JavaScript code into any pages the target visits. From here, we will build on this foundation. To perform more advanced actions. To begin, I am going to open a text editor on my Kali machine. So first of all, we move to the Kali machine and open a text editor. We will write a basic JavaScript code to display an alert message. The code will simply look like this: alert JavaScript test. On this script does is display a pop-up saying JavaScript test. Now I will save this file as a alert.js in my root directory. Next, we will use BetaCap to inject this JavaScript into target's browser. Specifically, we will modify the HSTS hijack plugin. Let me open the plugin configuration file located in user share BetaCap caplets HSTS hijack and open the HSTS hijack.cap file into a text editor. This file already inject a keylogger JavaScript file, but we will add our own script by editing the payload section. I will insert this line to inject our JavaScript file into every page the target loads. So type it colon and paste the path of alert.js. I copy that and paste here write name of the file and also add the comma here. This tell BetaCap to inject the alert.js file to all web pages. I will save the changes and now we are ready to test it out. Now I will run BetaCap with the same command we have been using to launch ARP spoofing and put ourselves in the middle of the connection. With BetaCap running smoothly, I will launch the HSTS hijack plugin. So press HS and tap for autocomplete. Once it loads, it will begin injecting the JavaScript payload, which include both the keylogger or our alert.js file. Now whenever our target loads any web pages, they will see the alert message. Let's check it. Open the target machine and check it out. Now I will be enter worldweb.com. As you can see, the pop-up are shown JavaScript test and press OK. Now try another one. Let's check into another website. Type s3cloud.in. As you can see, the pop-up messages are appeared. This simple demo shows how easy it is to inject JavaScript into any pages loaded by the target browser. This is just the start. By injecting JavaScript, we can do far more than display an alert. We can steal data, modify content, and more. In future videos, we will dive deeper into how to create more functional and stealthy JavaScript injection that can bypass security and remain undetected. This will give you a better understanding of how attackers exploit web vulnerabilities. So stay tuned for the next session. Where we will explore advanced JavaScript exploitation techniques and browsers manipulation. So see you in the next video. In this lecture, we are going to talk about Wireshark, an essential tool for network administrators. Now, Wireshark is a network protocol analyzer, not a hacking tool. It's designed for network administrator to monitor their networks, ensuring everything is working correctly and detecting any suspicious activities. Wireshark works by capturing network traffic through your selected interface. It could be your wired or wireless card. Once you select an interface, Wireshark starts logging all the network traffic flowing through it. This data can then be analyzed in detail using its graphical interface, which provide powerful filtering and search options. Wireshark lets you filter packets based on protocol like HTTP, TCP, or even search for specific data such as cookies, post requests, or GET requests. This flexibility is why it's a popular tool for network troubleshooting. Now, let me show you how Wireshark works. So, first of all, we open terminal or from application menu, open Wireshark. We will launch Wireshark, select the interface connected to my network. In this case, ETH0. If I open a browser and visit google.com, you can immediately see the traffic being generated. But remember, Wireshark only capture traffic going through your own interface. For instance, traffic generated by other device, like my another Kali machine here, won't appear unless we perform something like ARP spoofing to become the man in the middle. This is where techniques like ARP spoofing come in handy. By becoming the man in the middle, we can intercept and capture the traffic of devices we can targeting. In future videos, we will explore creating fake access points and further diving into ARP spoofing. Here is an example using BetterCap for ARP spoofing. Run the BetterCap. Once the spoofing is successful, Wireshark will be capturing all traffic from the target machine. Now I open a google.com to our target machine. As you can see, the traffic from that device is now being logged by Wireshark on my Kali Linux machine. To wrap up, Wireshark is a tool for logging and analyzing packets that pass through your interface. It's powerful for network monitoring, but is not inherently a hacking tool. In the next video, we will take a deeper look at how to use Wireshark for packet sniffing and analysis. And I will see you in the next video, where we will dive deeper into packet sniffing and traffic analyzing using Wireshark. Welcome back. In the previous video, we explored how to launch Wireshark and analyze pre-captured packets. In today's session, we are going to a step further. We will capture packets in real time, generate some network traffic on a target machine, and use Wireshark to analyze it. I'm already positioned as a man in the middle, as we discussed before. To capture network traffic, we need to be in this position. The traffic flowing through the target machine is captured via the ETH0 interface, which we will use here. Before we start capturing, let's explore the capture option in the Wireshark. So, I will open my Kali machine and open Wireshark. Let's explore the capture option in Wireshark. First, you will see a list of network interfaces, each showing the amount of traffic passing through. In this case, traffic is occasionally being generated on ETH0 from the target machine. You can select the interfaces you want to capture from. Wireshark allows capturing from multiple interfaces at once by holding the control and selecting them. For this demo, we will focus on only ETH0. Next, we will move to the output section, where you can choose to store the captured packets. If you don't plan to analyze the packets immediately, you can save them and revisit them later using Wireshark. Now that we have selected ETH0, I will click Start to begin capturing. Any traffic flowing through ETH0, whether it's image, messages, cookies, or any other data, will be captured and displayed by Wireshark. To see some actual data, I will generate traffic on the target machine. Before that, I will head back to BetterCap and use the HSTS caplet to downgrade HTTPS HS and hit enter. This way the data will be unencrypted and we can inspect it easily in Wireshark. Now I will run the caplet and return to the Wireshark. Now let's generate some traffic by visiting a website. So I open my target machine. First thing is, we need to remove browsing data by pressing Ctrl+Shift+Delete and clear now, and open some HTTP website like Google. Cloud.ie. Now I will search for s3cloud.in. Since everything is loading over HTTP, we will be able to inspect and analyze it clearly. Let's go back to Wireshark and see how the captured data looks. I'll stop the packet capture and now we can scan analyze the result. I will stop the packet capture and now we can analyze the results. Each row in Wireshark represents a captured packet. You will see a various columns including packet number. Each packet has its own number. Shows when the packet was captured. And now we can analyze the results. Each row in Wireshark represents a captured packet. You will see a various columns including packet number. Each packet has its own number. Timestamp shows when the packet was captured. Source, the device or IP address the packets originated from. Destination, the destination IP addresses of the packet. Protocol, display the protocol used like TCP, ICMP or ARP. Packets are color coded. Green for TCP, dark blue for DNS and light blue for UDP. Although we don't have any UDP packets at the moment, black indicates problematic TCP packets. So we have captured a lot of data, not all of it may be relevant to what you are looking for. In the next lecture, I will show you how to filter out unnecessary packets and focus on the ones that matter so we can extract useful information from them. Stay tuned for the next video where we dive deeper into packet filtering and analyzing with Wireshark. Hello friends, welcome back. I am going to walk you through a Wireshark and show you how to filter packets and focus on the useful stuff. You will be learn how to trace specific packets, understand what they mean, and dig deeper into each one to extract valuable information. So let's get started. Alright, so as you guys know, we have been working with a target computer and most of the traffic we generated so far is HTTP. Now, what I am going to show you is how to filter all that traffic so we can only see HTTP packets, which are much easier to analyze. It's super simple to do this. Just come over filter section and type HTTP. As you can see now, Wireshark is only showing us to HTTP traffic. This traffic is typically sent by browsers. And since we have downgraded HTTPS to HTTP in our demo setup, everything the target does in their browser will now appear as HTTP. Whether they are watching videos, browsing websites, or looking at images, Wireshark will capture all of it. So let's break down this packet here. We can see this request was sent from the target's computer's IP address to a public IP address on the internet. So this packet is going out to a server, not staying with the local network. When I double click on this record, you will see all the details of the packet pop-up. We have got information about the frame, which include things like the size of the packet and the interface it was sent on, and the exact timestamp of when it was sent. But more importantly, if we look down here, we can see the source MAC addresses and the destination MAC address. Remember when we talked about packets earlier, every packet travels from a source MAC to a destination MAC. This is how devices identify each other on a network. So this packet went from our target's IP to server's IP on the internet. Cool, right? Now, if we look at the transmission protocol section, it gives us port information. This packet was sent to port 80, which is the default port of HTTP traffic. Now, the most important part for us is the HTTPS section. This is where the real data is. If we expand this section, we can see the full content of the packet. For example, this packet contains a GET request sent to a google.ie. So, this is literally when the target type google.ie. For example, this packet contains a GET request sent to google.ie. So, this is literally when the target type google.ie into their browser. Wireshark capture it all. You can even see the HTTP headers, which give you more detail about the request. This is super useful if you want to understand exactly what is being sent and received between the browser and the website. Now, let's say you want to follow an entire conversation between the target and the website. Wireshark lets you do that too. Just right click on the packet, select follow and HTTP stream. Here we go. Wireshark shows us both the request and the responses. For example, we can see that the responses to this request included a PNG file. For example, we can see that the responses to this request included a PNG image. And if you scroll down, and you can even see the raw data of the image being transferred. Now, if we keep scrolling down, we can find other types of data. For example, here we can see a JavaScript file being loaded by Google. And here is another GET request where the target searched for something. Let's click on it and check it out. Let's click on it and check it out. As you can see, the target searched for LinkedIn on Google. Wireshark captured the full URL include the search terms. So we can literally see exactly what the target typed in the search bar. Alright, so that's a quick introduction to using Wireshark to filter and analyze HTTP traffic. We have seen how to focus on HTTP packets, trace the path of data, and even extract the exact data sent in browser request. Don't worry if this seems a bit overwhelming at first. We will be using this technique in future lectures to dive deeper into packets analysis and find some really interesting stuff. So stay tuned for the next lecture where we will explore more advanced packet filtering techniques. See you in the next video. Welcome back everyone. In this lecture we are going to dive into using Wireshark to discover data sent through forms, specifically focusing on how usernames and password can be captured when someone fill out a form on a website. This will give us a good understanding of how data is transferred during login attempts, especially in insecure environments. Now I have already got BetterCap running in the background, so I am acting as the man in the middle. Let's switch over to Wireshark where I will start a new capture. I have set the filter to only capture HTTP packets. So it's going to show me only the HTTP traffic. Let's navigate to a test website for this demo. So it's going to show me only the HTTP traffic. Let's navigate to our target machine and open browser. And let's navigate to a test website. For this demo, I am going to use oneweb.com. Keep in mind that this is an HTTP website, so the data we send here is not encrypted. Open the first link. As mentioned in previous lessons, we know we need to target an HTTP login page. But don't worry, we have also covered how to bypass HTTPS and HSTS. So if you need to downgrade a site from HTTPS to HTTP, that's something we have already learned. For this example, I will log in with the username admin and the password is 123456. Once I hit login, Wireshark should capture all the packets related to this transaction. Now that we have done, let's try something a bit more advanced. We will head over to a site that uses HTTPS. Like LinkedIn.com. LinkedIn.com. I will downgrade it to HTTP, and once that's done, we will try to capture login data as well. Click signing button for login. And I will log in with a sample username and password. Let's use s3cloudhub@gmail.com and enter password 1234567890 and press signing. Now back to Wireshark to analyze the data. Where things get interesting. I will stop capturing now, and what we need to focus on are the post requests. Login forms and most form submission and data using post. So if you are hunting for login information, this is where you should look. Scrolling through, we can see a post request to the login page on oneweb.com. Let's expand that and take a closer look at the HTML form data. As expected, we see the username as the admin and the password as the 123456, clearly visible. Now I close it. Further down, we find the post request for linkedin.com. As you can see, here is the login form. Just double click and let's expand this and scroll down to the HTML form data. Again, we can see the login credentials. Here is the username st-cloudhub@gmail.com and here is the password 1234567890. This demonstration shows how powerful Wireshark can be when it comes to capturing data flowing through a network. Even though BetterCap is great at sniffing password, sometimes it might miss filtering out usernames or other details. But with Wireshark, we capture everything that passes through our network interface. Now I minimize the Wireshark, and one cool thing you can do with BetterCap is to save all the data it captures into a file. You can do this by modifying the caplet configuration. Open our caplet, locate our caplet file and open it into a text editor. So add the command here and type net.sniff.output /root /capture file .cap. Press Ctrl F to save it. This will store all captured data into a cap file, which you can then open in Wireshark for further analysis. This is really handy if you are working on a resource constrained device, like a small laptop or even a phone. One last tip, Wireshark's find features is incredibly useful. You can use Ctrl F to search for specific terms in the captured packets. For example, if you are looking for a login attempts for a username S3CloudHub, just search for the keyword S3CloudHub. This feature makes it super easy to find login names and specific tags or any other details that may have been captured. And that's it for this lecture. I hope this gives you a clear understanding of how to capture form data, including usernames and passwords, using Wireshark. Remember, always practice ethically and legally. Stay tuned for more lectures on how to enhance your skill in network analysis and ethical hacking. So, see you in the next one. Welcome back everyone. In our previous lecture, we explored how once we are connected to a network, it's practically game over. By leveraging techniques like ARP spoofing, we have been able to redirect the flow of network packets, effectively making ourselves the man in the middle. This allows us to spy on users, steal their credentials, and even redirect them to malicious websites. What you have seen so far is just the beginning of what you can do when you are in the position. In this video, we are going to take it up a notch. I am going to show you another powerful method to become the man in the middle without needing to exploit ARP or any other protocols. And guess what? Once you are the man in the middle, you can execute all the attacks you have learned so far and many more that you can explore in the future. Let's start by reviewing something basic. Remember the diagram we discussed earlier when we were learning about how networks work. The access point or the router is the only device with direct access to the internet. Clients like your phone or laptop send requests to this access point, which then forwards those requests to the internet, retrieves the responses, and send them back to the clients. But what if we as a hackers replace this access point with our computer? In other words, what if we create a fake Wi-Fi network that provides real internet access? When people connect to our network, we automatically become the man in the middle because we are now acting as their router. We won't need to exploit any protocols or run complicated attacks. People will willingly send us their data because they think they are connected to a legitimate network. This is where things get really interesting. By creating our own Wi-Fi networks, clients who connect to it will automatically send all their requests through us. And since we are the router, we can see everything they do. We will forward their request to the internet and send back responses, just like a real access point. But in the process, we will be able to intercept sniff, and manipulate the traffic however we like once the client are connected. We can launch all of the man-in-the-middle attacks we have demonstrated earlier without needing to run ARP spoofing or anything fancy. All you need is computer running Kali Linux, internet access, and a wireless interface capable of broadcasting the Wi-Fi signal. Now let's break down what you will need. Internet connection. This could be through a Wi-Fi, Ethernet, a 3G 4G dongle, or even a virtual interface. Wi-Fi interface, not just any Wi-Fi adapter, will work. It needs to be capable of running in access point mode. Once you have set up the necessary hardware, we will be able to start broadcasting our fake network. With this setup, our computer will act like a router. Clients who connect to the network will send all their traffic to us by default. So we won't need to worry about ARP spoofing. We are automatically the man in the middle. From there, you can run all the attacks we have covered previously or any other man in the middle attacks techniques, like sniffing passwords, injecting malicious code, or redirecting user to a phishing site. Now, you could configure all of this manually. For example, you could set up the wireless interface to broadcast the signal, configure routing between interfaces, and ensure that traffic is forwarded properly. However, since this is the ethical hacking course, I want to show you a faster and more straightforward way to achieving the small result. The tool we will use is called the Mana Toolkit. This is a powerful suite of tools that allow us to automatically create a fake access point, sniff traffic, and even bypass HTTPS in some cases. It has three main scripts to choose from. Start no upstream.sh. This creates a fake access point without internet access, which is not very useful for our purposes. Start net simple.sh. This sets up a fake access point with internet access. Next, start net full sh. This also provides internet access but tries to automatically sniff traffic, which often fails. I recommend starting with not simple and then launching another terminal to run BetterCap for sniffing data and bypassing HTTPS, as we have shown in previous videos. Once our fake access point is live, clients will connect thinking they are accessing the internet. In reality, their traffic is flowing through our machine. We will use tools like BetterCap and Wireshark to analyze and manipulate the data. We can capture usernames, passwords, session tokens, and much more. This method of creating a fake access point is a powerful way to become the man in the middle and run a variety of attacks. It eliminates the need to exploit ARP protocols or other vulnerabilities. Clients will willingly send us their data. Hello everyone. In today's session, we are going to explore how to detect ARP poisoning attacks. ARP poisoning is common attacks where hackers manipulate network traffic, and we'll demonstrate how to identify this. First off, let's take a look at the ARP tables on Windows device. Every device maintains an ARP table, which maps IP addresses to MAC addresses. This is how devices identify each other on a network. Let me run a command to display the ARP table using ARP A. Here you can see the IP address of our router is 192.168.73.2 and it's linked to this MAC address, and this is the MAC address of the router. Now let's quick recap how ARP poisoning works. As we discussed before, ARP requests and responses are based on trust. Hackers take advantage of this by sending false ARP responses to the device, pretending to be the router. The victim device then believes the hacker's MAC address belongs to the routers and update its ARP table. The hacker also points the router, making it think their MAC address is associated with the victim's IP. For example, here you can see the IP address of our router 192.168.73.2 and it's linked to this MAC address. This is the MAC address of the router. Now let's quick recap how ARP poisoning works. As we discussed before, ARP requests and responses are based on trust. Hackers take advantage of this by sending false ARP responses to devices. The victim's device then believes the hacker's MAC address belongs to the router and updates its ARP table. The hacker also poisons the router, making it think that MAC address is associated with the victim's IP address. As a result, all network traffic flows through the hacker's device, allowing them to read, analyze, or even modify the data. This is how a hacker becomes the man in the middle. Now let's perform an ARP poisoning attack. I am already running the ARP poisoning attack. So after running the attack, I will check the ARP table again. Notice the MAC address of the router has changed to the different value, which is the attacker's MAC address. As you can see, the both MAC address are same. If we compare this with the attacker's device using ifconfig, you will see the MAC addresses match. This confirms that ARP poisoning has occurred. While manually comparing ARP table entries can help detect an attacks, it's not convenient to run these commands continuously. This is where tools like Sharp come in handy. Sharp automatically monitor ARP tables entries and alert us when something suspicious happens. It's available for Linux and Windows, and you can easily download it by searching Sharp. Now, let's see how it works. I have already installed Sharp. So, open the Sharp. Now, let's see how it works. I have already installed Sharp, and everything looks good for now. After running ARP poisoning attack, immediately Sharp notify us the router's MAC address has changed, indicate an attack. It shows the original MAC address and the new attacker's MAC address. With the Sharp, we can also identify the attacker's machine. Here we can see the machine is 192.168.73.131. Is responsible for ARP poisoning. Easy to pinpoint which device is performing the attack. So, as you can see, Sharp simplifies the process of detecting ARP poisoning attacks. It monitors the network for you and provides alert whenever there are suspicious activity. I hope this demonstration has helped you to understand ARP poisoning detection. So, see you in the next video. Hello everyone, welcome back. In today's video, we are going to see how to use Wireshark to detect suspicious activity on our network. Specifically ARP related attacks like ARP request storm and ARP poisoning. Let's dive into it. First, let's get Wireshark ready for the task. We need to configure it to detect ARP request storms. To do this, head over to the Edit Preference tab, select Protocols, then find ARP. Now enable the option that says Detect ARP request storms. What this does is alert us if someone is trying to map all the devices on the network by sending a large number of ARP requests. This is one of the common way attackers gather information about a network. Once this is enabled, Wireshark will notify us if it detects any ARP storms. Now let's click OK and start our capture. Now let's switch over to our Kali machine and use NetDiscover to scan the network. Now let's switch over to our Kali machine and use NetDiscover to scan the network. We are not going to perform an ARP poisoning attack just yet, but simply discover all the connected devices using the same command as before. NetDiscover I 58.0 range, in my case 192.168.73.1/24 and hit enter. NetDiscover has completed the scan and it found all the devices on our network. Now let's go back to Wireshark to see what's happening. Before we check for notification, let's analyze the packet generated by the scan. We can see there is a device identified by its source IP, broadcasting to the entire network. It's asking questions like who has this IP and tell this IP. This is essentially NetDiscover in action, trying to map every possible IP on the network and asking them to report back to the source, which in this case is the machine with IP 192.168.73.189. So we can easily deduce that someone on the network is attempting to identify all the connected devices. Now let's check for any alerts. If we go to Analyze and select Export Information, you will see that Wireshark has flagged an ARP packet storm. This tells us that a simple device is sending a large number of ARP requests. most likely trying to gather information about the connected devices. This is a clear indication of suspicious behavior. Now let's perform an ARP poisoning attack and see if Wireshark pick it up. I am going to execute attack using BetterCap in my Kali machine. Once the attack is in progress, let's head back to Wireshark and analyze the results. Look at this, Wireshark has flagged another issue, a warning about a duplicate IP address. This tells us that our router's IP address is now associated with the two different MAC addresses, meaning someone is tampering with our ARP table. This is the result of an ARP poisoning attack, where the attacker positioned himself between the router and the target device to intercept communication. So, how can we protect ourselves against ARP poisoning? One way is to use static ARP tables. Let me show you how we can. Let me show you what I mean. Open terminal and enter ARP. A. You can configure each IP address manually to map it. You can configure each IP address manually to its corresponding MAC addresses. In this case, when you set your ARP table to be static, any attempts to change it, like an ARP poisoning attack, will be blocked by the system. The downside is that in large networks, managing static ARP tables is an impractical, but in smaller setups like a home or a small office network, this method could be highly effective in preventing ARP poisoning attack. And that's how you can use Wireshark to detect suspicious activity on networks, including ARP request storms and ARP poisoning attacks. We have also discussed how you can defend against these attacks using static ARP tables. Thanks for watching and see you in the next video. Hello everyone, welcome back. In the previous lectures, we learned how to detect ARP spoofing attack by manually analyzing ARP tables. We also explored how to install tools like SHARP to automatically detect ARP spoofing without needing to check ARP tables manually. Plus, we used Wireshark to detect other suspicious activity on the network. While this is a great, there are few limitations. First, these are all detection techniques. So even if we detect someone intercepting our connection, there is not much we can do besides disconnecting from the network. On a public network, like at an airport, hotel, or college, disconnecting and finding another network is our only real option since we can't change the password. The second issue is that this method only works when the attackers become the man in the middle. But what if they are using another method? For example, they could be running a fake access point that we accidentally connect to. Or maybe we are on a public Wi-Fi and either the network admin or a hacker has gained access and is collecting data. The detection method we previously discussed won't be effective in these scenarios. That's why in this lecture I am going to show you two solutions that can help you to protect your data. Whether you suspect you are under attack or are connecting to a network you don't control. The solution to all of these issues is to intercept your traffic. The solution to all of this issue is to encrypt your traffic. When your traffic is encrypted, it does not matter if someone intercepts it because the data will be in a form they can use. Several methods can achieve this, and I will explore how they work as we can go through it. Let's take a look at how an attack might work first. I already have BetterCap running here, and as you can see, it's gathering information. If we click anything, you will notice that the domain is being detected. Now, let me quickly log into a website. You will see that this login attempt is detected with the username. Now, let me quickly log in into the website. Press login button and enter password paste and login. Now login successful. Let's move to the Kali machine and scroll down for login credentials. Now you will see that this login attempt is detected with the username admin and the password is test. Now I will open a new tab and go to linkedin.com. Type www.linkedin .com. Notice that it loads over HTTP instead of HTTPS. And if I log in here, and I will be able to capture the password. My Kali machine can intercept all the data sent between my Windows machine and the websites. Now enter username s3cloud@gmail.com and password is test 123456789 and click sign in. Now let's move to the Kali machine. If I log in here, I will be able to capture the password. My Kali machine can intercept all the data sent between my Windows machine and the website. To stop this type of attack, the first thing we can do is install a browser plugin called HTTPS Everywhere. So open browser and search HTTPS Everywhere plugin or add-ons. And here is the first website of plugin. Add to this into your browser. Once installed, it sets to off, but when we click it, we can turn it on. This plugin essentially works by enforcing HTTPS connection for websites that support HTTPS but may default to HTTP. While this is a great solution, it is not perfect. For example, if we go back to a website that only supports HTTP, like oneweb.com, login in will still expose my password to anyone. If we go back to a website that only supports HTTP, like OneWeb, login will still expose my password to anyone, intercepting the connection. In this case, HTTPS alone is not enough to fully secure the connection. To enhance your security further, I recommend using a VPN, Virtual Private Network. A VPN encrypts all of your internet traffic. Not just the traffic on HTTPS site, making it much harder for attackers to intercept or analyze your data. Here is how you can set up a VPN. Choose a reputable VPN provider. Look for one with strong encryption and no logs policy. Install the VPN application. Download and install the app from your provider's website. And third step is open the app and connect to a server, and from that moment on, all of your internet traffic will be encrypted. And step 4, use tools like IP leak test to ensure your real IP address is hidden and your VPN is working correctly. By combining tools like HTTPS Everywhere with a VPN, you can significantly increase your online security and privacy. Even if an attacker intercepts your traffic, they won't be able to read it. So, in summary, while HTTPS helps secure specific websites, a VPN adds a more comprehensive layers of protections, especially when using public or unsecured network. Stay vigilant and always layer your security to stay protected online. Thanks for watching, and I will see you in the next lecture. Hello everyone, welcome back. Now that you have learned the basics, it's time to take things a step further. In this video, we will explore how to gain access to different computer systems, whether it's a computer, server, or any electronic device. Yes, you heard that right, any electronic device. So, what is a computer? When I say computer, I don't just mean desktops or laptops. It could be your phone, TV, router, or even a web server. All these devices work like computers because they have an operating system and application installed on them. They might look different, but deep down, they are very similar to your personal computer. Targeting personal computers, today we will focus on how to gain access to personal computers, specifically Windows and Linux devices. But the good news is, once you understand the basic, you can apply the same technique to other devices like phone or web servers. All these devices function similarly when it comes to security and access. Now, when it comes to gaining access to this device, we have two main approaches: server-side attacks and client-side attack. In server-side attack method, we don't need any interaction from the user. It's usually done on the web servers or applications where no one is actively using the device. Here we will focus on attacking the operating system or the app installed on it to gain access. Second, client-side attack. This method needs the user to perform an action like clicking on a file, installing an update, or downloading something from the internet. Information gathering becomes important in this case because knowing the user's behavior can help you plan the attack. Once you have gained access, whether through a server side or client side or physical method, we will explore the next steps. This could involve exploiting the system further or gaining access or gaining higher privileges, allowing us more control over the device or network. So that's the big picture of what we are going to cover. Every device you interact with is a computer in some form. And the methods to gain access remain quite consistent. Stay tuned as we dive deeper into these techniques and learn how to secure system against them. So see you in the next video. Welcome back friends. In the upcoming lectures, we are diving into server-side attacks. But before we jump in, let's first understand what server is and how to attack it. To practice these attacks, we need a virtual machine acting as a server, just like we had a Windows machine to practice attacks on regular users. Now we need a server-like virtual machine. This will allow us to simulate server-side attacks and understand how hacking server is. This will allow us to simulate server-side attacks and understand how hacking servers work. The machine we will use is called Metasploitable, a Linux-based virtual machine designed for security testing. It is preloaded with typical server services and web applications, which we will target in our future lessons. You can download Metasploitable from the link I have provided in the lecture's resources. Once you are on the download page, click the download button to download zip file. As you can see, the download getting started. Once downloaded, you will get a zip file. And I have already downloaded an extra kit here inside the folder. You will find several files and we will use this to set up a virtual machine. Let's create a new virtual machine in VMware. So first of all, we need to open VMware and open a virtual machine. Select the folder and open VMX file and press the power on this virtual machine. The machine is now up and running. So it's asking for the username, which is MSF admin, and the password is also MSF admin. Remember, when typing the password, nothing will appear on the screen for security reasons. One important thing, never expose this machine to the internet, as it is intentionally vulnerable. Right now, it is safely isolated in our lab environment. When you are done using the machine, type sudo power off to safely shut it down. This ensures the machine power off clearly. So that's it. We have successfully set up our Metasploitable virtual machine, which we will be using in upcoming lessons to explore server-side attacks. Now, it will ask for admin password. So I will enter MSF admin. So don't worry about the terminal interface. We will go step by step and explore everything along the way. See you in the next lecture.